Good morning, colleagues. Can you hear me? Great, thank you. Okay, good morning. I'm going to start the session. It's a small group of um, people this morning. There should be more here, but that's fine. It's a Saturday morning, so I suppose there's other things going on. I'm just going to load the slides quickly. No, I can't see them. Um, There we go. Okay. All right. So the session this morning, we're going to be covering themes of reliability and validity and also measurement and data collection tools. I've just changed the sequencing of the session because I was going to start with measurement, and then I decided to cover reliability and validity first. But before I get on to that, I just want to, sorry, can you see my slides on the screen? Because I can't see them and I need to find out why they're not showing up. Can you see my slides?
Good morning. Yes, we can.
Okay, thank you. Yeah. So I just need to make a note to follow up on this because I don't know why it's not. I need to follow up with IT to find out why it's not showing up for me. All right. So just before we start on the research methods, I just want to just quickly mention some general ideas relating to supervision. So it's not related to the methods specifically, but I have shared a paper with you by Anne Lee, which is about how our doctoral students supervised, and she focuses on 5 concepts which are sort of deemed to be important for student success in terms of supervision. So the themes are, or the concepts are enculturation, which is where the student is encouraged to become a member of the disciplinary community. And we did speak about that in the first unit where the student can be encouraged to join a conversation in terms of the research that they're doing, so that they become part of a academic community within the discipline that they're working in, or within the topic that they're working in. The second theme is critical thinking, where the student is encouraged to question and analyze their work. So that's obviously just to get the student to think about what they're doing critically, not just to go ahead and do the research without really thinking about what they're doing, but to sort of to think about it more in a more critical manner. And then there's emancipation, which is, and that's in relation to the work that they're doing, the project work. And then the third theme was emancipation, where the students are encouraged to question and develop themselves. So that's a more personal growth, or it could be growth as a researcher. But they're sort of, I think when we do research, we develop as when we interact with our topic, for example, and when we develop, as we accumulate qualifications, there is a sort of process of emancipation which occurs there. And then in terms of supervision, there's developing a quality relationship. So that's where the supervisor would find ways of enthusing, inspiring, and caring for the student. So that's more about the relationship between the student and the supervisor. And then there's the functional dimension, which is which is related to the project management. So it's helping the student meet their targets in terms of having to complete certain tasks by certain dates and so on. Making sure they've or having a supervisor-student agreement in place, and making sure that they submit the correct documentation and so on and so forth. So it's quite an interesting paper, and it gives ideas in terms of the things or the factors which are thought to be important for students to succeed in their research journey. And it's not just about the project itself, or the research that they're doing. It's about broader issues around the process of doing research. So it's not directly related to, this could be related to quantitative or qualitative or mixed methods. It's not specific to a particular methodology, but I think it's an interesting paper about the kinds of factors which influence students having a good journey. Okay, I'm now going to talk quickly about assignment 2. So I'm just going to change the screen quickly. I see so that should be loaded now. Sorry, I'm not having a. Okay, so assignment 2. So you should see a Word document on the screen. So what I'm asking you to do in assignment 2 is to find two. The assignment focuses on validity and reliability, which we're going to be talking about today. And what I'm asking you to do for this assignment is to, and it's this kind of assignment is related to your when as a supervisor, you kind of expected to be a subject expert. So the question is, how do you become a subject expert? And that develops partly through doing research, but one way is to look at other people's research and work out what they're doing, and critiquing the work of other people in terms of. So in this particular exercise, we're focusing on validity and reliability specifically. So it's quite concentrated in terms of the focus. So what I've asked you to do here is to choose 2 research articles in your discipline, and to focus. They need to be quantitative articles. So I think, even though I couldn't find proposals for some disciplines from our archive at StatCon, there will be there's pretty sure to be some quantitative research being done in the area that you work in. So to find, or not necessarily the topic field that you work in, but in the discipline that you work in, there should be some quantitative work done. So to find 2 papers and then to look at how those papers deal with validity and reliability. So what do they say about the reliability and validity of their research that they're doing? Also, just to bear in mind that, so usually most quantitative research papers will have a sort of quite specific coverage of reliability and validity. But sometimes, depending on the discipline, they might not use that terminology. They might say they might refer to accuracy or consistency. Or if they don't cover those topics at all, that's also interesting, because sometimes what's not there is also relevant. So theoretically, there should be some coverage of validity and reliability. And part of this exercise is to look at so when we look at reliability and validity, there's different forms of reliability and validity. As I go through the session this morning, I'll talk about different types of reliability and validity. So, and not all of them will be relevant to every discipline. They won't all be relevant to a particular piece of research. So it's to try and establish within your discipline what are the main themes in terms of which are the main forms of reliability and validity that the researchers refer to. And then just to kind of do a critical kind of review of the so the exercise is about sort of identifying what forms of validity and reliability are covered by the researchers, and then are they correctly defined. Sometimes when people publish work, it's not always accurate. So sometimes there'll be reference to a particular type of validity which is not actually accurate. So it's just to kind of look at the way the validity and reliability have been defined and used, and to sort of assess whether it's done correctly or not. And then if it's not done correctly, what kind of form of validity would you suggest it is? Yeah, so hopefully most of the time the validity and reliability will be explained correctly, but sometimes it might not be. And then the other thing would be There's threats to validity and reliability. We'll look at some of those as well. And do they mention those, and how did they address them at all? So is there any coverage of the potential threats to validity or reliability, and have they been covered? So one of the reasons for this exercise is that as consultants, we sometimes get asked by researchers, how can I make sure my instrument is valid? And it's quite difficult to answer that question. There are you'll see that when we go through the session, there are certain things that I can do as a statistician to test reliability and validity. But it's not that simple. There's lots of different forms of validity, for example. And when you're not when you're not familiar with the particular topic, it might be quite difficult to establish or understand whether there is a validity and reliability in that particular area. So it's quite a difficult question to answer as a consultant. We can give some suggestions, but it's not always easy to answer that question and to ensure that research is going to be valid and reliable when we helping with the design. So sometimes, yeah, it's not an easy issue to address. So part of this activity is also to look at how validity and reliability are dealt with. And I'll talk about some of the ways people deal with it during the session, which could be good or bad. So that's this part of this exercise is trying to understand how validity and reliability are used in the discipline, and so that if a student comes to you and says, how do I make sure my instrument is valid? You can give them some suggestions on that. Okay, so I've given you a reference. It's a very short chapter on reliability and validity of instruments. They're mainly focusing on sort of questionnaire-based instruments, but they also do have some reference to sort of equipment-based instruments as well. And then for the assignment, what you need to do is just provide a short report summarizing the paper, the purpose of the assignment, citing the two papers that you're using. So you can include URLs for those two papers if there is URLs, and then review the coverage of validity and reliability in the research papers. And then just a reflection of your experience as a researcher and supervisor in relation to validity and reliability, which is stage 3, and then a short conclusion. So it's a fairly short document, just going through the reliability and validity of the papers and evaluating what the authors have presented. Have they done enough? Is there too little or too much coverage? Are you convinced by the coverage that they've provided? If they haven't provided any, then that's obviously also a weakness of the paper. But just be careful that sometimes people might not refer to it specifically as validity and reliability. They might have information there that's providing evidence of validity and reliability, but not sort of explicitly stated as such. Okay, so that's assignment 2. Right, I'm going to stop sharing that. And then assignment 3 is going to be, I hope you're going to enjoy this one. Right, so assignment 3, there should be a document on the screen, which is there should be a Word document on the screen. So for this one, what I'm asking you to do for this assignment is to generate a toolbox of resources that you can use as a supervisor to assist or to support students who are doing quantitative-based research projects. So you might have some tools already I'm saying tools, but I mean resources. So you might have some resources that you use already to guide students when they're trying to learn about research and when they're trying to implement research for their projects. So this activity is basically to kind of, so there's 2 parts to it. One part is finding a resource which will help the student, and then another part is finding a resource which will help you as a supervisor to evaluate the work of the students. So there's 2 components to it. The one is about helping the student, the other is about helping yourself as a supervisor. or supporting yourself as a supervisor. So there's two. I'm going to skip through the sort of background. So what you need to do is you need to identify resources for two purposes, and I'll explain what the resources can be when we get to the additional criteria. So what I'm calling knowledge resources, so those would be resources to support the student towards their understanding of excellent research design and implementation for the various stages of the quantitative research-based journey. So we're covering in this module, we're covering the whole range of stages in the research journey for quantitative research. So it's from conceptualization through to writing up the findings and reporting the findings for the study, publishing the findings. So you can look for resources at any of those stages. So it could be at the conceptualization phase. So just as an example, if you think that so one of the things I think students struggle with is understanding conceptual and theoretical frameworks. So you might choose a resource which helps the student understand what a theoretical framework is or what a theoretical proposition is, for example. So if you're doing a quantitative-based project, if you're supervising a student who's doing a quantitative-based project, they would need to think about a theoretical proposition, for example. And that chapter by Wetton, for example, would be a good chapter to give them to look at, to say this is what a theoretical proposition is. If you're doing a PhD, this is how you can add new theory to existing theory. So that would be an example of a publication-based resource that you could include in your portfolio, in your toolbox to assist the student or to guide the student as a supervisor. The second, but you could also choose something for analysis, for example. So it doesn't have to be you can ignore the conceptualization phase completely if you want to. You could choose resources for other phases of the research journey. Okay, then for the evaluation resources, they're resources to help you as a supervisor towards being able to critically evaluate the work completed by the student when they're conducting quantitative research. So an example of a tool there would be, or I'm saying tool, resource would be the chapter by Anderson Daniels where there's a set of questions that you ask around the research design, which help you sort of evaluate whether the research design is good or not. I'm going to be sharing another paper with you as well, where the authors have developed a rubric for evaluating written work submitted by students on their research, for example. So that's another resource that you might want to include there. So you will be able to get some resources from the program. You might have your own resources already that you could include, or you could find new ones. So there's different, it's up to you to decide which resources you want to include. So there's many potential resources. But you only need to produce 5 for the knowledge resources and 3 for the evaluation resources. So if you've got 10 knowledge resources that you could think about using, I've spoken about this idea of curating. So you want to choose the best 5 for your purposes. And remember, it's for your discipline. So I would expect to see different resources from different disciplines depending on which area of the research design you're focusing on. Okay, so you need to include 5 knowledge resources and 3 evaluation resources. And the resources must be for quantitative-based research. Okay, so and that could be purely quantitative or mixed methods, but not qualitative-based. Okay, so that although some of the tools some of the resources that you use could be used for both quantitative and qualitative, but as long as it's relevant for quantitative, then that's fine. Okay, so for example, conceptual frameworks can be relevant for quantitative and qualitative research. So if you're choosing a knowledge-based resource for conceptual frameworks, that could be used for quant or qual. So it's not what I'm trying to avoid though is for the qualitative people in the group choosing a qualitative resource for a quantitative purpose, which won't work well. Okay, so the resources must be relevant for your discipline. And also bear in mind here that many resources could be relevant for different disciplines. So, but some resources might be very specific for a particular discipline. Because disciplines can have very specific methodologies. So, for example, in the languages, in language research, there's very specific kinds of software and analysis that researchers use to analyze linguistic patterns. It's not a normal kind of analysis or sort of standard traditional kind of analysis that we do for general research. It's very specific to that discipline. So you can choose something, if it's relevant for your discipline, then you can choose it. The knowledge resources can cover different stages of the research journey. So, for example, any of the stages, it could be conceptualization, theoretical framework, theoretical propositions, the research design, the research strategy, populations and sampling, operationalization of measures, data collection, statistical analysis, interpreting and reporting findings. So any of the stages could be, you can choose resources which you think would be useful for the student to learn about research at any stage of the research process. You can include different forms of resources. So it could be publications, books, journals, articles. It could be video. It could be a YouTube video, for example. It could be a workshop that the students could attend. It could be a course that the students could attend. It could be a website which has lots of useful information on it, or it could be when I say team group, what I'm meaning there is that sometimes there could be a group of students who work together on a particular topic area, and the supervisor could set up a sort of group, a social group, not a work-related social group, where the students can communicate about their topics. Or it could be something in Moodle, for example, where a group of students, a Moodle site where they can communicate about their research. So when I talk about team and group, it's some kind of resource where the students can work on so they can be part of a community. So maybe I should use the word community rather than team and group. So it'll be a research community. Okay, so for each resource, you need to include the following: a brief, clear description of the resource, a justification for why the resource is relevant for quantitative research in your discipline, an explanation of what phase of the research journey the resource will be used for and then a motivation for why you've chosen to include that resource in your supervisor toolbox, an explanation for how the resource will be shared with and used by the student, that's the knowledge resources, and an explanation for how the resource will be used by yourself if it's an evaluation resource. Okay, the thinking behind that question is sometimes we have resources and then just the last point is an explanation of how you would evaluate the effectiveness of sharing or using the resource. So the thinking behind that is that sometimes we have a resource that we might give to a student, but we don't know whether they're going to use it. So how are we going to evaluate if they've used it effectively or not? And that's in terms of trying to evaluate the usefulness of the resources moving forward. Is it something that we can keep using, or is it something that we drop? So, for example, as a sort of consultant, there's certain resources that I share with students to help them understand things better. But because I'm not supervising the student directly, I'm not always sure whether that resource has been helpful or not. Because I don't follow them through their full journey. But as a supervisor, if you're working with students, you will be able to, obviously you'll carry on working with them through to the end of the process. So you'd have a better idea of whether you can see whether that tool is working or not. We do get resources back from students. Sorry, we get instruments back from students for second reviews and third reviews and so on. So there are ways I can see whether the tools that I'm sharing with the students are working. Yeah, so it's just a kind of an idea of, is it useful, is it working, or is it something that's would be and this is not, you might not know at this point because if it's something that you haven't used before, it still has to be tested, but it's just to get an idea of how you're going to use it and how you're going to make sure that the student is using it, for example, effectively. Okay, so for the product, you need to, I'm avoiding the word portfolio, although in some ways this will be a portfolio of resources. So I'm just rather calling it a toolbox. So you need to submit a document which lists and explains the resources you've selected. So obviously, if you're choosing a video, for example, you're not going to include the video you can include a link to the video and explain what the video is covering. You're not going to actually sort of attach the video to your submission. I don't expect to see the video itself or the group or the community if you are linking the student, but you can sort of explain what the community is, for example. Okay, and then you just need to answer the question, each of the sort of issues that have been raised for each of the resources. So why have you chosen that one? Why is it relevant to the discipline? Which stage is it going to be relevant for? How is it going to be used how do you anticipate it will be used by the student? And how sustainable do you think the use will be? Okay, this one's a bit longer. So this is the bigger assignment. And I think I've forgotten to put the date in here, but it will be on the, let's make a note of that date. Okay, so that's assignment 3, I beg your pardon. So that's the last one. And I think, yeah, and if you already have resources that you use for students, which you think work effectively, then those could be included in this toolbox. Okay, so just bear that in mind. Right, and you can use resources which I'm sharing with you in the course, which you think might be useful to take forward to use for the students. Okay, so I'm going to stop sharing that now. Are there any questions about the assignments? Okay, good. Right, so I do need to provide the rubrics for the assignments. Was there a question? Yes, Victoria, yeah.
Yes, good morning. Good morning, Prof.
Yes, hi.
Thank you so much for the explanation. I want to know, when are we submitting the assignment 3?
It's later in October, so I think it's about the 25th or something. I can't remember the exact date.
Okay, so thank you so much.
Yeah, it's obviously it's got to be after assignment 2, but things are going to get quite tight at the end of October because we have deadlines for examiners and so on, so examinations and faculty and so on. But we'll put pressure on you towards the end. Okay. All right, then I'm going to put some additional resources on Moodle. So I've got some papers on experimental design. So for those of you who are doing experimental design or who would think it might be useful to do experimental design, if you haven't used it, there will be some papers there. And then I'm also going to put a research paper which is essentially a tool for supervisors where the researchers have developed a rubric for assessing research writing of students, basically. So it could apply to a proposal, it could apply to their dissertation or a paper that they're publishing from their research. So it's quite an interesting paper, and it gives quite a nice structure for. It kind of has the elements that you would need for that, or sort of breaks down the a publication in terms of the components of the publication, and then has a rubric for evaluating the different components that should be in some kind of research publication. So I'll put that on. I can't remember the names of the authors, but I'll share that on Moodle, and I'll send an email when it's shared. Okay, so and again, that's something that you could use as an evaluation resource for the last activity, for the last assignment. So it's trying to find tools you can use as a supervisor to help structure your evaluation work that you have to do when you're working with student work. Okay. Okay, I've done something wrong here. Sorry. I'm still in Teams, which is good. Okay, sorry. Oh, my slides have gone. Okay, I'm just going to move this on. Okay, there we go. Right. Okay, so in the first part of the session today, we're going to talk about reliability and validity. I want to go through this, and then we'll take a break after this. After I've covered reliability and validity, we'll take a break, and then continue with the second component. And then let's see how far we get with the material. And then I think also the other thing I wanted to ask you is if there's anything that you not covering that you would like to cover, then just let me know, just so that I can make sure that we integrate it somehow before because we've got 2 more sessions after this session. But if there's something because we need to cover the statistical component of the analysis component, and all the data and the analysis component in the next 2 sessions after this. But if there's anything else that you want to have more detail on, then we can maybe look at that. Okay. So with reliability and validity, these are 2 important concepts for quantitative research. Because it kind of speaks to the quality of the research that we're doing. So we can have this situation where we have reliable information, but it's not valid. So what that means is that we've got consistent information, but we're not measuring what we thought we were measuring. So that's a problem. And validity in some ways is both validity and reliability are important. But validity in some ways is more critical than reliability, because you want to make sure you need to know that you're measuring what you're measuring, what you think you're measuring, rather than measuring something else. You don't want to say I'm measuring entrepreneurial orientation and then you're measuring some other concept. So that's why validity is so important. What we also want to avoid a situation where we've got data which is not reliable or valid. And that's the second image where we haven't measured the construct of interest and our data points are all over the place, and that can happen. But we need to avoid that. That's the worst kind of scenario. And then, the ideal situation is where we've got valid. That's the third figure, is where we've got valid and reliable information. So we've measured what we think we're measuring accurately, and we've also got consistent measurement for that variable that we're measuring. So that's what we're targeting. And different factors can affect the validity and the reliability of the measures. Okay, just come back here. All right. So very crudely, reliability is consistency or repeatability, and validity is accuracy. So when you think about these 2 concepts, those are the kind of very basic sort of simple definition of what each one is. Validity is accuracy. Are we measuring what we think we're supposed to be measuring? And reliability is, are we measuring the variable consistently, or can we repeat the measurement successfully? So they're very, as I mentioned, they're very important for quantitative research design. In qualitative research, we don't speak about reliability and validity. We talk about other factors which speak to the quality of the research, like credibility and trustworthiness. And the reason for that is it's related to you'll see when we come to the statistical part of the analysis. with qualitative research, because it's normally small samples and different sources of data, it's not, you need to find other ways of demonstrating the quality of the information. Whereas if we have a bigger sample, we can use statistics to demonstrate reliability and validity. So, and it gives you a more convincing kind of evidence of the accuracy and the consistency of the data that you're working with. So the debates relating to reliability and validity are complex. So I'm going to cover some of the issues today, but it's much more complex than we can cover in an hour or two. So just bear that in mind. The other thing is, what I find quite surprising is that the research methods textbooks, there's many textbooks on research methods, but they often don't give a lot of space to reliability and validity. They focus more on sort of strategies, so they will cover the issues, but not in a lot of depth. So that's also it's quite an interesting issue. But I think there's another reason for that, is that they cover. There's quite because they're quite complex concepts, and the debates around the concepts are quite complex. It's not easy to cover them in a quick sort of easy way, which you would expect to see in a general research methods book. So examiners and reviewers will often ask how reliability and validity have been achieved. So if you're a quantitative researcher, you'll be looking out for reliability and validity, and that's part of the reason why activity 2 or assignment 2 is there, is to kind of draw the focus to these two issues, which are quite critical for quantitative research. And then obviously your students must attempt to maximize the reliability and validity during their design phase. It's just, there's certain things that you can try and do to minimize or to maximize the validity and reliability of your study. And there's certain things that you can look for which would help you which would sort of raise red flags almost about validity and reliability of studies. So, and I'll try and cover some of those as we go through the material. But as I also noted earlier, it's quite, when somebody comes to you and says, how do I make sure this is valid? There isn't really an easy answer to that question, because there's lots of different forms of validity. So there's one kind of validity which is fairly easy to speak to, but it's the weakest form of validity. So it's not that easy to answer that question. Okay, so just before we go on to the material, I'm not going to do a group thing because we don't have lots of people. Let me just put this another way. So we're in your discipline. Do you focus on, let me ask the question this way. In your discipline, do you focus on validity and reliability, and how important is it for your discipline? So let me put that question to you. You can talk to the group. Let's do this through you just unmuting and speaking to so the question is, in your discipline, is there a focus on validity and reliability, and how important are those two concepts in your discipline? Yes, Nicoline, yeah.
Thanks, Doc. So my discipline, just to refresh everyone's minds, is forensic anthropology. And because it has a legal component, validity and reliability is actually extremely important, because it also has a population variation component. Validity is often checked in multiple populations. It is one form of research that's actually often conducted in anthropology, where a method is tested for validity in multiple different populations. And then reliability is normally checked. A study will not be able to be published without reliability being discussed in the paper. So reliability is normally checked. If it's an observational scoring criteria, we normally use a Cohen's kappa. And if it's a measurement, we have very specific anthropology tools that we actually check internal consistency and observer agreement for the measurements.
Okay, good. So I'm going to hand over to you when I get to the reliability section. Okay. Yeah. Anybody else? So with the any other disciplines, how do you is there a focus on validity and reliability, and what emphasis is given to those two concepts? Yes, Tony. Yeah.
Thank you. Within my discipline, which is philosophy, there is less emphasis on reliability, as we don't usually work with the kind of variables and things that would be testable in, like, to be consistent with reliability. We do have some sort of way to assess things over time, but we don't have the kind of the accurate kind of measurements that would be necessary for testing of reliability or assessing reliability. But I think with validity, I think it's much more closer to what we do. But yeah, that's just my comment on reliability.
Okay, thanks. I think the issue with your comment about the reliability is it's not so much you don't have the measurements, or that you don't have the sort of statistics or whatever to measure it, but that you just don't use you don't measure things in the way where you could use the measures, because the measures are there, or the statistics are there. It's just that the measurement isn't done in a way such that you could use the statistics. But so I'm going to do a quick demo later on of how we do the analysis, and you'd have to think about how you could measure something in a way which would allow you to do, I'm sure there are ways there's research that you could do in philosophy, which would allow you to use the statistics which we use to measure reliability and so on. It's just not done a lot. I think that's the issue. Yeah. So just Nicoline, just to follow up on your comments about forensic anthropology, it's very interesting, because I think anthropology as a discipline is much more associated with kind of qualitative research, and I would say, the more qualitative kinds of approaches to providing evidence for quality. So it would be credibility, trustworthiness, and so on. But because it's a forensic anthropology, that sort of changes the emphasis quite significantly, I think, and that kind of makes it much more quantitative or evidence-based, which is interesting. Yeah. Okay. Anybody else who would like to talk about their field and the focus that field has on validity and reliability? Before we move on. Okay. All right. I'm just going to move on then. Okay. So right. So this is these are the desiderata from the chapter by Knapp and Muller. This chapter is also from the book Designing Research for Publication. No, it's not from that book. It's from Reviewing Quantitative Research. I beg your pardon, getting my resources mixed up. So this is from the book. This chapter is from the book Reviewing Quantitative Research, and the chapter's on reliability and validity. So the first point is that each instrument used in the study is described in sufficient detail, so that when they refer to instrument here, it could be a physical machine, it could be a piece of equipment, or it could be a questionnaire-based instrument. So instrument could mean multiple things here. And then the appropriateness of the instrument to address the study's purposes and research questions is made explicit. So that's just saying that you need to indicate that why the instrument is relevant for the purpose of the research. But that's fairly obvious. The second point is appropriate reliability indices are considered. So there's different, you'll see when we talk about reliability, there's different kinds of reliability that we can measure. And then the study's purposes guide the choice of indices calculated from current data and or examined from previous research. So that's quite an important point there. So when you're trying to demonstrate reliability, we can get data from, we can measure reliability from the data that we get from our study if it's appropriate to do so. And I'll show an example of that a bit later. Or you can also use previous research to make the argument that the instrument that you're using is reliable. Okay, so sometimes what happens is, so in psychology, it's quite common. So the psychologists use questionnaires in the form of psychometric instruments sometimes to collect data from subjects. And what they won't necessarily calculate the reliability for the sample that they get for their study. It might be too small because a lot of these statistical procedures are reliant on a certain sample size. So what they would do is they would say, okay, well, somebody else did this research using this instrument, and they've shown it to be valid and reliable. And then, so they're using previous evidence rather than their own evidence from their own study. If you can do both, then it's stronger, but you might have to rely on what somebody else has done before you to argue for reliability. And the same thing would apply for a physical instrument. So if you're using a piece of equipment to measure something for your study, measure a variable for your study, you can probably test the reliability for your own data, but you might have to rely on what somebody else has done previously to sort of argue that you have a reliable instrument. So that's it's the point. The key point here is that you could use data that you've collected yourself to try and do the measurement, or you could use previous research to argue that your instrument is reliable. Okay, the third desiderata is, or desideratum, is suitable validity evidence is gathered. The study's purpose determined the type of validity support gathered from current data and or consulted from a related literature. So this is also speaking to the same issue. I'll give you a couple of examples of validity a bit later. So you can, what you need to try and do for your research is to show that the instrument that you're using, for example, is valid. And you could do that from current data that you have, and I'll give you a demonstration of how we can try and do that a bit later if it works. And then, or you could use current or related literature to show that when other researchers have shown that that particular instrument is valid, you then use that as your evidence to say, I'm using an instrument which is kind of valid. If you can do both, it's better, but there might be instances where you can't do both, and you might have to rely on previous literature to make the point of validity. Okay, and then the fourth point is just applicable reliability and validity evidence is reported and interpreted. The study's conclusions are placed within the context of such evidence or lack thereof. So it's also important for researchers to note that if they haven't got previous evidence of validity and they can't show it from their own study, that they don't have that evidence to demonstrate validity and reliability, and that would make the research a bit weaker in terms of these two concepts. So it's important so there's different ways you can bring in reliability and validity for a study. And one way of making your study stronger is to use instruments which have been shown by previous researchers to be valid and reliable. But sometimes the quality of the instruments or the quality of the research out there is not good. So you might end up using an instrument which is, although the researcher argues that it's valid and reliable, it might not be that good. So that you just have to be careful with those kinds of things. Okay, so there's three types of reliability we can measure. So there's internal consistency, which is it's where that for this kind of measurement we have a scale that we want to measure, some kind of measurement that we want to take, and there'll be a number of what we call items making up that scale, and then that measurement. So then we can measure the consistency of responses. I'm going to give you an example of that, sort of demonstration of that in a minute. And we can use a statistic called, one of the statistics we can use to measure that is called Cronbach alpha. And this is what we call item to item consistency. But it's also important to bear in mind that it's not possible or not always necessary to measure reliability. So in the quote here is different accessible beliefs may be inconsistent with each other. So sometimes when we have a set of questions, they're not intended to be measured as a single scale. So for example, there's something that we measure called the standard of living index, and that has a number of for that index, you ask people whether they own certain objects like a bike or a car or a fridge or a spade, for example. So there's a whole range of different objects that you ask the household if they own any of those things, but they're not meant to be related to each other. It's not like we're trying to measure something which is that we don't really, it doesn't matter whether somebody has a spade or not. But there's other kinds of scales where the items are supposed to be related to each other. And we'll look at an example in a minute about of a kind of scale like that. So, but that's item consistency, and we can use a statistic called Cronbach alpha to measure that. And I'll explain a bit about what that Cronbach alpha means in a minute. And then the second kind of reliability is repeatability. So that's where it's a time-to-time based measurement. And this we measure, we want to know whether something is repeatable. So what we would do there is we'd measure the variable, and then we would measure it again and see whether we get a good correlation between the two measurements. So we call this a test-retest correlation. So we measure, and then we measure again, and we look at the correlation between the two measures, and that will tell us whether there's a good, obviously the higher the correlation, the better the reliability is. And then the third type of measure is consistency of ratings or scores. So this is a rater-to-rater measurement. So sometimes when you ask people to, when people are doing research, you might be asking somebody to make a judgment about something or to score something. So I recently worked on a project with a student from, I think it was chiropractic. What she was doing was trying to look at the content of websites to see whether the websites were covering the right kind of information about the topic that she was focusing on. So what she would do is she would go to the websites and she would she would kind of read the material and then code to code certain information. So the rater to rating consistency is if you've got one person doing that, you don't know whether how accurately they are or how consistently they are rating the information on the pages. So you need a second person to rate, to do the same coding or code the same information to see whether they come up with the same codes. And then if you can demonstrate that the coders are coming up with the same codes, then that means that you've got consistent rating happening. If they come up with different coding, then your system isn't working very well. And I've given you a paper as part of the course by an author called Halgren. So one of the things about all these types of reliability is that they're always a bit more complicated than they look like. So for the rater-to-rater rating, there's a paper by Halgren where he goes into very a lot of sort of in-depth detail about the different kinds of rating that you can do and the kinds of tests that you can use to test the inter-rater reliability, depending on the measurement that you've taken, this kind of thing. So if you're doing rater-to-rater reliability, the paper by Halgren is a good resource to look at for getting detail about the nuances of inter-rater reliability. Okay, so I'm now going to switch to another program, and I'm going to show you some statistics. I'm just going to do one of them, I think, because we're already quite, just going to stop sharing the screen. I just need to load another program quickly. I won't be a second. I hope. I'm just going to close this down. Let's get rid of that. Okay, I'm just going to try and share my screen now. I'm not sure if this is going to work, but let's see what happens. Okay. You should see on the screen now a sort of database, something that looks a bit like a database with a list, some columns and some rows. Can you see that on the screen?
Hi, yes, we can.
Okay, good, thanks. Okay, all right. So this is a data set from a student that's doing research looking at, I'm not going to go into detail about the topic, but basically one of the variables that she's measuring is it's a variable called entrepreneurial orientation. And that's the sort of dependent variable for the study. And that's made up of three subcomponents, which is risk, proactiveness, and innovation. So the entrepreneurial orientation is made up of, is argued, is conceptualized to be made up of three different subdimensions: risk, proactiveness, innovation. So the statements making up those, whoops, I didn't mean to do that. That's not supposed to happen. So each of those, this is not working. Let me just undo that. Okay, I'm just going to have to, not sure why this is, I think maybe because I've got all of those selected. Let's try this. Yeah, that's better. Okay, so each of those concepts is made up of a set of questions to measure those concepts. So for example, the risk component is made up of, I encourage people in my company to take risks with new ideas. I value new strategies, plans, even if we are not certain they will always work. To make effective changes in my offering, I'm willing to accept at least a moderate level of risk. I engage in risky investments. Okay, so the people who've developed this scale have argued that those statements are good representation of risk-taking, for this idea of entrepreneurial orientation. The innovation would be statements like, I highly value new product lines. Regarding problem solving, I value creative new solutions. I consider my business services products as innovative. So each of these statements is kind of been designed to measure this idea of innovation as part of your entrepreneurial orientation. So if we look at the data for these questions, I'm going to go to the end here. You should see another screen, which is a slightly different window, which shows the data. Can you see a different screen now with a lot of unsure, disagree, strongly disagree on it?
Yes, we can.
Yeah, okay. So if we look at the, I haven't gone far enough here. So if we look at the innovation, for example, the scoring system that would be used for that would be an extent scale. So to a large extent, to no extent, to a moderate extent, for example. If we have consistency, which is when we're measuring reliability as internal consistency, so item to item consistency, what we want to see, if these statements are measuring innovation, the person who's answering them should choose answers which are in, so they usually use what they call an ordinal scale here. It's usually a 5-point scale. Sometimes it can be a 7-point or a 3-point or a 4-point scale. It varies. But if the person is answering consistently, they should choose within the same range of responses. So, for example, this first person has said for the first innovation question, to a very large extent, to a very large extent, to a large extent, to a large extent, to a large extent. So that's fairly consistent in terms of how they've answered. If the innovation questions weren't working as a scale, or if they weren't related to each other, then you wouldn't necessarily expect to see this kind of consistency of responses. Let's look at we'll see if somebody said to a small extent. Yeah. So this person here, person number 14, has said to a small extent, to a small extent, to a small extent, to no extent, to no extent for those innovation questions. So they're obviously not very innovatively orientated. But the key point about it is that they're choosing answers, or they're choosing the response options, which are very close to each other on the lower end of the scale. So they're giving a very consistent kind of answer to that question. So we want to measure to see whether we want to kind of get a measurement to see how consistent the answers are in terms of their rating. So if we go to analyze, I'm running a program called SPSS here, which I'll go into more detail with in a later session. This is the program we use for statistical analysis. And if we go to scale, there's a scale option on the menu here, and then there's an option here called reliability analysis. So that's where we would get that's where we would look to get the option for, in this case, we're talking about internal consistency. Okay, so I'm going to put the items in. I'm kind of guessing here a bit. Hoping I've got the right ones here. So I'm going to take those 5 questions which measure innovativeness, and I'm going to put them in under items. You'll see here that there's an option here saying alpha. There's also split half and Goodman and other parallel. So remember, I said the analysis or the options can be much more complicated than I'm suggesting here, or that I'm showing. So there's lots of other options you can choose from depending on what you're doing. And then I'm not going to I'm not going to choose any of these other things here, because I think we should get the Cronbach alpha, which is the thing that we most, I'm going to choose the scale if item is deleted. That should be enough. Okay, so, all right, so these are, what I'm going to get from this is a Cronbach alpha, and I'll explain what that is when we get the result. I assume at the moment you can see there's a box on the screen which says reliability analysis.
Yes, we can.
Yeah, okay, good. I'm just making sure that you can see what I'm seeing. Okay, so if I run that, I get a result here with a result which is Cronbach alpha. So what the program has done for the 132 cases in the database, there's 5 people who don't have an answer for one of the questions. So we've got 127 responses, but we're getting a Cronbach alpha of 0.824. Which is a good consistency. Yes, yeah.
I think we can't see the SPSS output screen.
Oh, okay. What can you see?
We're still seeing the data set.
Okay, let me see if I can get that. Thank you for that. Let me just try and share if there's another screen here. Yeah, there we go. Okay. So this is the, thanks for noting that. So this is the Cronbach alpha for those 5 statements measuring innovation. And the Cronbach alpha is 0.824, which is a good value. So the Cronbach alpha ranges from 0 to 1. if it's naught, that means that it would mean that you've got no consistency at all. If you've got 1, it means that you've got perfect consistency, and that very, very rarely would happen. You shouldn't, if you're getting a Cronbach alpha of 1, it means somebody's fiddled the data. Okay, so somebody's cheated on their data usually. So 0.84 is a very good value. We normally, when we're looking for values for reliability, the sort of cutoff value that we would normally consider to be a good reliability is 0.8 or higher. So this is a good internal consistency, but depending on what research you're doing, we might accept lower values than that. So 0.7 might also be considered decent. And sometimes people will also work with low values than that. Although if you go below 0.7, it's starting to get a bit problematic in terms of being able to argue that there is a reliable scale. Okay, so so when you're doing research and you want to show that your work is reliable, and you would only do it if you have this kind of scale to work with, then you can get your Cronbach alpha, and then you can say, great, I've got a reliable scale here. So that's your piece of evidence to tell the person who's reviewing your work that you have this reliable instrument that you're working with. Okay, in this case, it's a latent variable that we're working with called innovation. Okay, so that's how we would get a result for the Cronbach alpha. So if somebody's using a scale like this, they should be reporting Cronbach alphas, and you want to see good Cronbach alphas. You want to see sort of high values for your Cronbach alphas. You don't want to be, if somebody's reporting a Cronbach alpha of 0.5, it should be a red flag saying, no, that's not a good reliability. So these are some of the things that we use as evaluators of people's research. And so when a student comes with their proposal, and if they're talking about they should mention that if they're using a pre-existing questionnaire, there should be some mention of the reliability of that questionnaire or the measurements that are being used on the questionnaire. And then you look at those figures and say, okay, they look reasonable, or are they poor? So there's different kind of numbers that we can look at to sort of establish whether they are sort of appropriate or not. Okay, I'm just going to stop sharing this now. And then for the other two, I just need to work out. I don't think I've got, I can't close that down. I'm just going to open up another file. So it's very easy to run Cronbach alphas, and it's very easy to I need to work out what I've got on the screen here. Okay, so let me just go here, share. Okay, this is another file where we've got raters. So this is the second kind of reliability. Well, another kind of reliability would be inter-rater reliability. So here we've got different, what we call judges or raters, rating a particular issue. So judge 1, judge 2, judge 3. If we go to analyze, again, we go down to the scale variable, reliability analysis. And in this case, we would put the information under ratings. Okay, so here we go. I'm just going to use 2 judges here. And here we'd be looking for the ratings of the judges. Then under this option, we can get there's something called the intra-class correlation coefficient here, which we can use to assess judges. And there's different models that we can use. So there's two-way mixed, two-way random, and so on. I'm not going to go into detail about what the difference is between them. This has to do with whether you know who the judges are or not, basically. That will determine which kind of model you use. Are the judges known or are they not known? That's the criteria for deciding on the type of model. And then there's a consistency or absolute agreement. So we can use consistency or absolute agreement to decide whether you can have different model. So absolute agreement would test whether the judges, that would be testing whether the judges are exactly the same rating, or consistency would be more about the consistency of the rating. So I'm just going to use consistency, and then if we go continue, and then okay, we're going to get a kappa agreement result, which I just need to toggle for the window. So I'm terrified of getting knocked out of Teams here. This leave button is far too close to the share button. Okay, so this is a result from that analysis, and it's a very poor agreement. So this group of judges, or the two judges that I've just analyzed, are not in good agreement for the items that they're scoring. So that would mean that that would probably suggest that you need to have different criteria, or maybe use different judges who are more similar in terms of their judging ability. Okay, so this kappa statistic would probably range between -1 and +1. It's unusual to get a minus kappa, but it just indicates how poor the agreement is between the judges, or the consistency is between those two judges. Okay, so you can also do get a kappa statistic from a crosstab, but I'm not going to show that now. But yeah, so these are some of the ways that you can test for different types of reliability, and then the other type of reliability, which is the pre-test. It's like a pre-test post. It's not a pre-test post-test, because it's the test retest correlation. That's where we're looking for time to time. There we would use a correlation to look at the relationship between the measurement before and after, or the other two measurements, to see whether there's been and what you'd expect to see there is a good correlation between the two measurements, the measurement that you take at the first point in time and the measurement you take at the second point in time. If there's poor correlation, it means that you're not getting good reliability across time, and that's not good for measurement. Okay, and the same if you're doing machine-based reliability, you would want to. There are obvious ways that you would. So if you think about when we use a scale, for example, to measure something, to measure the weight of something, we set the scale, we set it to 0, and then we'll put an object on that scale to measure it. So one way of testing the reliability of that kind of a piece of equipment is to replicate the measurement. So what we would do is we'd put a piece of or an object on the scale, measure it, and then take it off again, put it on again, take it off again, put it on again, and that would give us an indication of how variable the measurement was for that particular instrument that we're using. So usually when people are using instruments, they will calibrate and then take multiple measurements and then look at the variation in that measurement to determine how much variation there is. And obviously, the more variation, the less reliable the instrument is being. Okay. Then I'm going to be borrowing from some slides from a person called Robert Michael for the next few slides when we come to validity. So validity relates to our ability to claim, a relationship exists between an independent and dependent variable. So we should be back to the slides on the screen now, I hope. And then, so that's internal validity, and then external validity relates to our ability to claim the results of the study are applicable to other contexts or groups, and that can sometimes be more difficult to argue. So there's two broad forms of validity, and then within each of these there's different sort of types of validity as well. And then it's also important to think that an experimental design, or some kind of design where we can control the variables, allows us to control for threats to internal and external validity. So when you've got control, if you're doing an experiment in a lab, for example, you've got much more control over the variables that could influence the study than if you're doing a natural experiment in the real world, where all sorts of things could affect the variables that you're working with. So that's kind of what makes working with people more difficult, because it's very difficult to control what people do in the world, in their sort of environment and their social. So some of the threats to internal validity are history. One of the threats to internal validity is what we call history. So that's if you're running a project, some unanticipated event might occur, and it could be that event that affects the dependent variable, not your variables that you're trying to control, or not the independent variables that you're thinking might affect the dependent variable. So, for example, if you're looking at electricity usage as the outcome variable, and then there's load shedding. The load shedding is what's influencing the electricity usage, not the lower usage by the public, for example. So it's these kind of unexpected events that might affect your dependent variable. If you're using a one group design, that's particularly, so that means that you only have one group in your experimental design or your sample. That's very vulnerable to history. So, and you won't know whether the effect or the outcome variable is being affected by the treatment or the event, this unexpected event that's occurred. A solution to that is to use a two-group design. So you have an experimental group and a control group. And if the history event occurs, it will occur for both groups, and then any differences that you see won't be due to the won't be due to the historical event that's occurred or to this unexpected event that's occurred. So there are ways. So a two-group design is usually better than a one-group design because of that, partly because of that reason. The second threat to internal validity would be maturation. So as we move through time, your sample or your subjects can change. So for example, if you're looking at, say, performance of learners, and that declines over time, it might be due to fatigue rather than due to the treatment that you are, rather than the treatment that you're trying to apply to the learners. So that's something to take. And again, the one group design could be a problem for maturation. And again, the solution to that is to use a two-group experimental control design. So if the maturation occurs similarly for both groups, then any difference observed will not be due to the maturation. So because you've got these two groups, and the one group has got the treatment over and above the control group. The only issue with this, sometimes, so ethically, a control group can be a problem because you're not giving them a treatment which might be valuable. So if your treatment works, your control group is not getting that treatment, and that's where the ethical dilemma comes in. But what you can do is design if you can show your treatment works, what you can then do is follow up with the control group and apply the treatment to them as well. So that's how you can sort of deal with that ethical issue of Okay, I'll just switch him off. Okay. So then there's also other threats to internal validity. That one would be statistical regression. And this is the idea that when if you've got a sample, the extreme cases would regress to the mean. So it's just this idea that if you're measuring something, your kind of cases will be your cases might end up being measured. The measurement might be more towards the mean than, so you lose your extreme cases. So that's an example of statistical regression. So it's just this. It's a problem with the sample where the sample is too close to the mean and not representing a true population. Then there's the selection threat. So this is particularly the case if you have a random versus voluntary sample. So if it's not a problem for a single group design, but if you've got voluntary selection or voluntary participation, it might be a problem for a two-group design. So your groups might end up being different in terms of their characteristics because of the volunteers, because of the nature of the volunteers which decide to go into each group. Then we have experimental mortality, or it could also be survey mortality as well, where participants or subjects drop out. And that can happen with experimental designs or with survey designs, particularly if you're doing a panel survey or a longitudinal survey. And then there's testing. When we test somebody in the beginning, it might sensitize them to the measurement that we're trying to, or the instrument that we're using. And their performance on the post-test might be due to the pre-test participation, not a treatment. And again, that's also an issue with the one group design. So most of these problems are related to one group designs rather than sort of multiple group designs. Okay, and then other threats would be instrumentation. So that would be an example where you have a poor instrument or an instrument that's not reliable, for example. That could then threaten the internal validity of the study. There's also design contamination. So this would be a contamination process that occurs that makes the experimental and control groups look more similar than they actually are. So you end up with two groups which are they're quite different, but they look the same, and they're not supposed to look the same. There's also something called compensatory rivalry. That's where participants in the control group, they know that there's an experimental group, and they increase their efforts because they know that they're not receiving the experimental treatment. So they behave in a different way because they're aware that there's another group that's getting something that they're not getting. Then there's also something called resentful demoralization, and that's where those in the control group, because they're not receiving the experimental treatment, become resentful, or the other where it could occur is that the experimental group is resentful because they think that the treatment that they're getting is inferior to the control group. So it's the two groups behaving in different ways because of, particularly if they're aware that there's another group participating. And then external validity includes population validity and ecological validity. And population validity relates to how representative the sample is of the population. And then ecological validity relates to how appropriate it would be to generalize the findings across settings. So this speaks to applying the study to a broader context. So moving beyond the study to bigger population or larger population, or to different settings, so different countries, for example, or different provinces. So it's kind of moving the study beyond the context that it's into to bigger kind of environments. So threats to external validity would include interaction effective testing. So this, when we measure things, there can be interactions between variables which could produce effects which then could be mistaken for the effect of the treatment variable. So it's not the treatment variables which are causing the effect on the dependent variable, it's the interactions between the variables which are affecting it. So it's, in some ways it could be like a moderation effect that's occurring, which is not what you would be expecting to see. Then there's also interaction effects of selection biases and the experimental treatment. So this is where some aspect of how participants were selected causes them to respond differently to treatment and control groups, or to the treatment and the control situation. Then there's also reactive effects of experimental arrangements. So this is where where the effects that we see in the experimental setting can't be generalized to the natural setting. So it's just the experimental setting is not really reflective of the natural setting. So what the results that you get for that experimental setting can't really be applied to the natural setting because of because something's going on within the the controlled experimental situation, which is not reflective of the natural environment. And then you can also get multiple treatment interference, and that's where, as multiple treatments are given to the same subjects, it's difficult to control for the effects of prior treatment. So you don't know which of the treatments is actually causing the outcome. It could be any one of them, and you can't necessarily control for those. Yeah, and there's just a link here to a website which gives some more detail about the threats to validity. All right, and then when we come to measurement of variables, there's different. I think I mentioned before. We speak of different kinds of validity that we can measure. So there's face validity. That's the most basic form of validity, and that the question there is: do items represent what it is that you want to measure? And the way we determine that is that, so if you're developing an instrument, or if you're using an instrument for measuring a variable, the way the researcher would normally establish face validity is to have experts look at the instrument and comment on its face validity. So, for example, if you're developing a questionnaire on a particular topic, you would get an expert in that field to look at the questionnaire and say, is this questionnaire measuring what it claims to measure? And the experts would say, that's a good idea. So there's a process called the Delphi method where the way that method works is that you get experts to comment on a particular problem. So you might sort of say, identify sort of a particular set of factors which you think are important for a particular issue. And then the experts would review those factors and comment and rate them in terms of the importance, for example. So that's a way of establishing face validity. It's to get people who know the field or the topic to make the point about the measurement. But it's not really a quantitative. You can do that quantitatively, but it's not really a quantitative. It's generally a more qualitative kind of form of validity. Then we have content validity, and we have the question there is, are the items well balanced? Are the items a well balanced sample of the domain content? And this can be tested using confirmatory factor analysis or item analysis. So there are statistical procedures we can use to measure content validity. I would also refer to that as factor validity. And then within this kind of confirmatory factor analysis, we can also measure something called convergent and divergent validity. And I'll talk about those a bit later. Then we've also got concurrent validity. That's where we correlate our measurement with another validated external measure, which is measured at the same time. So what we're doing there is what you would be doing there is, let's say, for example, you want to measure something like entrepreneurial orientation. You would have your measure of entrepreneurial orientation, and then you would find another validated measure of that construct, and you measure that at the same time, and then you can correlate those two, because if they're measuring the same thing, then they should be correlated with one another, and that's what we would say. That's how we refer to concurrent validity. And then we have construct validity, which is what we would do there is we would measure a variable which is known to correlate with another variable. So we know from the literature that the two variables correlate with, they're not the same variable, but they correlate with one another. We measure both of them, and then if we can show the correlation is there, then we've demonstrated construct validity. And then there's also predictive validity, which is we measure how well the construct predicts an expected outcome. So there we it's similar to construct validity, but you know that there's a relationship between the variables. One would be a sort of independent variable, one would be a dependent variable. You can measure them, and then we can look at the relationship between them. So these are different ways of establishing validity. And the kinds of validity that would be relevant for the discipline might be different. So just bear that in mind. Okay, and then I'm just going to, okay, I think I'm going to take a break now. And then when we come back, I will do a demonstration of how we would look at how we use confirmatory factor analysis to test a structure. Okay, so I'm going to, let's take a break now. It's 10:30. And then how long would you like for a break? And it'll give me some time to set up my other program. Is 10 minutes enough? 10 minutes?
Yes, thank you.
Okay, good. So it's 10:35. So we'll start again at 10:45. Okay. Right. Okay, the power just went off here. I'm at the office and the power just went off, so I'm feeling a bit. I think the um, generators come on. I hope. Okay. So you should see a program on the screen. There should be something that looks like a database. Can you see that?
Yes, we can.
Okay, so this is a program called EQS. So SPSS is a very powerful stats package, but it doesn't run statistics for a procedure called confirmatory factor analysis. So when you want to test your when you've got a questionnaire, for example, that you or some kind of variable or set of variables that you want to test a structure for to validate that structure. SPSS doesn't run confirmatory factor analysis. It runs a procedure called exploratory factor analysis, but not confirmatory factor analysis, which is where you want to confirm that your data meets a certain structure. So we use other programs for confirmatory factor analysis, which is why I switched to this program called EQS, which is the program that I use for confirmatory factor analysis and structural equation modeling. So, and I don't want to scare anybody off statistics by showing you this. It's just to demonstrate that this is how we would establish that we have a valid factor structure for our data. And that, so it's speaking to this issue of validity. And this is, so when we do stats as well, there's kind of different phases to the analysis. So this reliability and factor analysis is part of establishing that that you have the structure that you need for your variables, and you have the accuracy and the consistency that you're looking for the variables to establish that. This is the descriptive analysis and the correlations and the regressions and so on would come after you've established this particular set of analysis, well, after you've completed this kind of analysis. So this is getting to the point where you can work with the variables in the way that you expect to. So what I'm going to do here is I'm going to run a model. I'm going to create a factor model. So we've got this variable called entrepreneurial orientation, which is made up of three subfactors. So I've got the subfactors here. I'm just going to take the subfactors here. You should see that I'm building. I'm going to build three factors from those three subdimensions of entrepreneurial orientation. So I think you should see a box on the screen which says Factor Model Builder. And I've put three factors I've created three factors, and I'm now going to create a model. I'm not doing a prediction here. When you do a confirmatory factor analysis, you're just looking at, we call it a measurement model. So we're not looking at the relationship between an independent and a dependent variable. We're just looking at the structure of the factors to see whether they are reasonable or not. Okay, so I'm going to skip this menu here, which is basically building a structural equation or a regression model. But I do want to know what the factor correlations are, and I'll explain why I need those a bit later. Okay, so that's going to give me a graph. Can you see a sort of a diagram on the screen with factor 1, factor 2, factor 3, and so on?
Yes, we can.
Yes, you can. Okay, so this is the model that I'm going to test. So it's the conceptualized model of entrepreneurial orientation split into three subfactors, and each of the three subfactors has items attached to it. So I want to see whether the data fits this model. So I'm just going to, I wasn't expecting this. I'm just going to put a test here. Say, okay, I'm going to use robust methods, okay, and then I'm going to, hopefully this will work. I'm going to run the model. Okay, so I've got a diagram of the model. I'm going to run the model, and then this is the output file. So you should see a file on the screen which starts EQS, a structural equation model, and then it's got program control information and so on. Okay, can you see that output file?
Yes, we can.
Okay, good. Okay, so I'm going to skip. There's a lot of information in the file which is more sort of we use for diagnostic purposes, but I'm going to skip straight down to the fit statistics. So this is so when we run a model, we want to estimate how well the data fits to the model that we're proposing. Okay, and we use what we call fit statistics to estimate the fit of the model. So I'm looking at these fit statistics here, and the result is not good. So I'm looking at the what we call the NFI, the NNFI, and the CFI statistics, and there's certain levels that those statistics should be to indicate that the model is a good fit. And in this case, all the coefficients are below 0.9, which would be the sort of minimum value that we would be looking for a good fit. So I'm saying, and also this RMC statistic here should be around about 0.05, but it's actually 0.108. So it's not giving me a good, I'm not getting good fit statistics for this model. So what that's telling me is that the data that I've got for the model doesn't fit the model well. So it means I need to look at a different structure to what I've told EQS to analyze. So in terms of validity, I couldn't use if I proceeded now and said I've got this great structure, I've got the correct structure, I've got 3 subfactors and they're measuring. The statistics are telling me otherwise. The statistics are telling me, no, you don't have a valid structure there. It's not working the way you anticipated it to. So I would then go down, I'd have to run an EFA, which I'm not going to do now. But one thing I can do is if I look at the coefficients for the individual items, you can see in this table here, I can't select all of them, but so the 4th item, which is making up the risk factor, has got a very low coefficient, 0.281. So that item is not doing well with the other 3 items. This item here, innovation, one of the innovation items has got a low loading, so has or low coefficient. So has the 2nd innovation. So there's something poor about the items aren't relating well to the original factor. If I remove those items, I might get a better fit. But if I run this through a CFA, if I run this through an EFA. Sorry, can you still hear me?
Yes, we can.
Yeah, sorry, the power's going on and off here. It's gone off again. It's very nerve-wracking. Okay, so I'm not sure what's going on. If I disappear, the power's gone off, and I'll have to make a plan. Okay, so yeah, so the where am I? Okay. I should have stayed at home and done this from home. Okay. All right. So this result here tells me that there's some items which are not doing well on the factors. And if I run this data through an EFA, which is an exploratory factor analysis, what it does is it splits the innovation variable up into 2 separate variables. So the data is not working as a single variable, but it works as 2 separate variables for the innovations subfactor. So that's why, what is going on here? Sorry, can you still hear me?
Yes, we can.
Yeah, sorry, the power's going on and off like a yo-yo. It's very, very disturbing. Okay, so basically you've got a situation where we've got this wouldn't be considered a good factor structure based on the results that I'm getting from this confirmatory factor analysis. So we'd have to re-look at the structure and come up with a different structure, which is what I'm suggesting. The other piece of information that we use for determining discriminant and for discriminant validity. So we're going to use some information from this table here to measure convergent validity, and I'll explain that in a minute. And then we're going to use some information from this table here, which is the correlation between the factors, to measure divergent validity. So when we look at the correlation between factors, these are correlation coefficients between the three subdimensions of entrepreneurial orientation, and we don't want these correlations to be too high, and we don't want them to be too low. If they're very high, that means that the sub-factors are kind of the same. So what that would suggest is you can probably combine them together into one single variable instead of working with separate sub-variables. And if they're too low, it means that they're not really related to each other in a way that we might expect them to be if they're measuring this bigger concept of entrepreneurial orientation. So these correlations are important because they will tell us whether we have we don't, as I say, we don't want them to be too low, we don't want them to be too high, and then we'll use them to determine the discriminant validity of the factors that we're working with. Okay, so I'm going to stop. So that's an example of a CFA. In this case, confirmatory factor analysis. In this case, this hasn't worked. So we want, and when the CFA doesn't work, you then go to an exploratory factor analysis to see what alternative structure might work. Okay, but for this particular project, this result calls into question the validity of the original instrument that was proposed to be valid and reliable. Okay, we're not talking about reliability at this stage. We're talking about validity, factor validity, or content validity. Okay, so I'm going to now shift to another program. Just going to close that down. I'm going to go to Excel now. I'm jumping around a bit because we work in different programs. Some of the software will give you all the results that you need, but some won't. Okay. So this is an example of the coefficients that we get for each item making up a factor. So in this example, we've got two factors made up of specific questions. And then we've got the R-squared values. These are good. So this would indicate that we've got a good, you can see the fit statistics for this model are good. We've got NF5 0.96, 0.96, 0.96. We've got a decent RMC. So we've got good fit statistics for this model. And then we've got a correlation between the two variables, which is high, but it's not necessarily excessively high. So to calculate convergent and discriminant validity, we can take these coefficients and we can take the correlation here and use them in calculations to estimate convergent and discriminant validity. So these are examples of, I'm not going to go through the formulas and things, but we can take that information and we get a measure of convergent validity. We use another piece of software to calculate this. So there's another application that we use to calculate the values based on the coefficients that we have. But the point here is just to show you that we can calculate convergent and discriminant validity from the coefficients that we can get from data that we have. So as long as you've got a big enough sample and you've got the right kind of data, if your data is aligned to doing this kind of analysis, we can calculate estimates for convergent validity and discriminant validity. So when you publish the work, when you write up the work and publish the work, you can show these coefficients and you can demonstrate convergent and validity for the reader. And that makes the research much stronger in terms of validity. So in this case, when we measure convergent validity, we calculate something called the AVE. And I'm not going to go into detail about that now. I just want to, there's just a coefficient that we can calculate called the AVE. It's based on these numbers here, these coefficients, which is the coefficient of the item to the factor. And the criteria that we use is that if AVE is greater than 0.5, then it means that we've got convergent validity. And convergent validity refers to the relationship that the factors have on the, the items have on the factor. So if you've got good, if the items have a good sort of strong coefficient with the factor, then you're going to get good convergent validity. So it means that the items converge onto the factor. That's a way of thinking about it. Okay. And then there's different measures for discriminant validity. We can calculate coefficients. And the coefficients come from the correlation between the factors. We've got a coefficient called MSV, ASV, and the square root of the AVE. And again, we use criteria to decide based on the value of the MSV, for example. If the MSV is less than the AVE, then we can say that we have discriminant validity. If the ASV is less than the AVE, then we can say we have discriminant validity. And if our square root of the AVE is larger than any of the interconstruct correlations, then we can say that we have discriminant validity. So discriminant validity refers to the relationship between the variables that we're working with, so between the different subdimensions or the subfactors. And you don't, what I was suggesting was we don't want those correlations to be too high, and we don't want them to be too low. We want them to be sort of related, but not too strongly related or too weakly related. So for this particular project, the result was good reliability, good convergent validity, and good discriminant validity. And if you can report that, then you've got a much stronger case for your research is going to be much more convincing. Because you've shown that you've shown some characteristics about the variables which demonstrate that this validity is present. Whereas if it's not present, so for example, for the previous example, where the model didn't fit, that would indicate poor validity. So that would, and then you'd need to look at a new structure for that particular model. Okay, so those are some of the key. And then I think I mentioned for the other kinds of validity, like concurrent validity, for example, you could measure that there you would need to measure a different form of a construct at the same time. But the problem with doing that is that if you're using a questionnaire, for example, it means that you're going to have a longer questionnaire because you've got to add more questions to measure that construct a second time. Or if you're doing construct validity where you want to link that, or you want to demonstrate that the relationship works with another variable, which is known to work with, you have to measure that other variable as well, and that again is going to make your questionnaire longer. So you have to balance out the sort of need for demonstrating validity versus the kind of practicalities of getting a good response. Your response rate will go down if you have a very long questionnaire, for example. So you have to find the balance between one needing to show validity and reliability versus the practicalities of being able to do the research. It might be that your sample is too small. So for these measures of for a confirmatory factor analysis, for example, you need a bigger sample size. So if you've only got a sample size of 30, for example, you're not going to be able to do a confirmatory factor analysis. So you wouldn't be able to rely on that analysis. So you have to bear those things in mind when you are doing the analysis. Okay, so I'm going to share this again. What's going on here? Okay, so we've done that. What's going on here? Yeah, so I've spoken about convergent validity and divergent validity, and yeah, I've also covered that. You can correlate variables. Okay, so we're now going to move on to measurement, which is related to validity, because some of the issues that we've just spoken about relate to the measurement that you make. And first of all, looking at data collection tools. So we're moving down into the sort of very focused area of the research where the inner layer of the onion, where we're looking at data collection and data analysis. And at this point, we're talking about the data collection tools and developing those. So it's stage 4 of this particular structure. So we would be choosing the data collection instruments, and because we can measure validity and reliability of instruments, of the measurements, it's a good place to talk about validity and reliability, although that also refers to other sections of the research design as well. Okay, so when you're choosing data collection instruments, you may need to design a new instrument, or you may need to adapt an existing instrument, or you may use an existing instrument as it is. And this would apply for sort of machine-based, equipment-based instruments versus questionnaires, or experimental designs where you're using potentially different kinds of instruments to do the measurement. Okay, so we don't have to go to a breakaway group. So what kinds of instruments do you think we would use to collect quantitative data? What are the common instruments that we would use to collect quantitative data?
Categorical classification systems.
Right. Okay. Okay. What would that look like? So, what is the data going to be on or in for that kind of data collection?
It's normally a scoring system with a descriptor linked to a score.
Okay, so you'd put it, do you do it sort of on a database or in a paper-based kind of, you'd have a kind of form that you fill out, or either online,
yes.
Okay, so it's like a spreadsheet basically, or a paper-based system. Okay, so it's almost like a document in a way. Okay. What tools do we use to get quantitative data? Questionnaires. Yep, good. Okay, so I'm not a bit behind with this window. Surveys. Okay. Remember, the survey is a strategy, it's not the tool. So I like to distinguish between the strategy and the tool. So we've kind of moved down from the strategy to the actual instrument that we're going to be using. So to collect the data. So questionnaire, you'd use a questionnaire under surveys, you'd use a questionnaire, you could use a questionnaire in experimental design, you could use a questionnaire in a case study design. There's lots of different, there's not lots, but we can use the questionnaire for different strategies, and the survey is the strategy rather than the tool itself. Okay. I'm a stickler for classifying things into groups. So okay, measuring instruments such as calipers, good. So your instruments, there's lots of equipment that we use, and science researchers often use equipment for measuring things. There's literally a huge array of instruments that people use. They would have to be calibrated, set, and so on, and then there'll be various things that have to be checked and balanced on the machinery. So electronic health records extracted in Excel. Yes, So Yeah, so records, documents. So that's what I would classify as being documents. So patient records, newspaper articles, those are all websites. Those could all be sources of data for quantitative information. All right, so these are the tools that we could use, or instruments. So questionnaires would be a common, so the kind of tool that we work with mostly at StatCon would be questionnaires. But we also do get other forms of data. So for example, if a health science student is doing research on patients, they might measure various things about the patients, which they then input into an Excel sheet. But they would probably use some form of documentation or an instrument to measure. They've got a thing called an algometer, which measures pain, for example. So they get the pain measurement from the equipment, and then that goes into a spreadsheet. Then we've got documents. So so I put instruments, equipment at the bottom here. There's lots of different kinds of instruments that researchers can use to collect data. Then there's documents, for example, internet websites, records. There's also a group of methods called participatory methods, which are not well kind of known, but they're not extensively used, partly because of the issues of validity and reliability, but you can get quantitative data from them. Observation, we usually would use structured observation to collect quantitative data. Participatory observation is more associated with qualitative work, and the structured observation would usually be in some kind of experimental kind of design, or there'd be a very structured sort of set of questions that you'd be asking, or activities that you'd be looking for a structured observation. You could potentially also use interviews for quantitative data. The one thing that I'm quite strict about is distinguishing between interviews and questionnaires. So often a student will write and say that they're using a questionnaire, and then they will refer to doing an interview, which might mean that they're administering a face-to-face questionnaire. But I like to distinguish between a questionnaire and an interview, because I think for me they're two very different forms of data collection. So they're not the same thing. All right, so oops, I'm going on here. All right, so we've asked you that. So yeah, so is there anybody who uses a instrument, a machine, or a piece of equipment for data collection who can give us a quick overview of what they use and some issues around it in terms of operation and how they test the validity and reliability of the measurement? So I should take that out this week, discussing it down. Ignore the last sentence. So is there anybody that uses an instrument for their, a physical instrument for their data collection, for their measurement? So like a microscope or a spectrometer or something like that. Okay, nobody. Okay, or nobody wanting to talk about it. All right, so I'm going to focus on questionnaire design, because it's one of the things that I think most people, or not most people, but a lot of people will use questionnaires for their research. So I just want to spend a bit of time talking about questionnaires. And it's also a way of covering some of the issues around research, which are important for the data collection tool. So I think a question would be, we don't have to do it in groups again because it's a small group. But if you think about, if you were developing a questionnaire as a data collection tool, what criteria would you include on a checklist to achieve a high quality questionnaire? So if you're going to be using a questionnaire to develop for your data collection, and there's certain things that you would need to think about for that questionnaire in terms of making sure that you're going to get a good quality result from that questionnaire. So so the question is, what criteria, what list of factors or criteria would you include on your questionnaire design list to ensure that you're going to get good quality, a good quality questionnaire? Okay, so I'm going to leave it up to you now to tell me what you think should be included. You can either unmute and say, or otherwise just type it in the chat group.
I would like to comment, Doc. I'd say a good questionnaire allows for a range of responses, not just sometimes yes or no, but sometimes allows for an in-between. So it should have a range of responses, which are, number one, something manageable, but also allows the participants to give, or rather the variables to have more options.
Yeah, so I think it's a good point. So you need to make sure that the person has a choice of responses which allow them to answer. So there's nothing more frustrating when you're trying to answer a questionnaire and you don't have the option that you want to say, which does happen quite regularly, actually, with questionnaires. I'm sure you've filled out questionnaires for institutions where you think, okay, well, I can't answer this question because the option that I need to choose isn't there. Sometimes it's a don't know or not applicable. But yeah, I always use the example of when UJ did a survey some years ago now about, it was a culture survey or something, and one of the questions was, does your manager go to gym? And I thought, I really don't know the answer to that question, but they hadn't given you a don't know option. That was just strongly agree, strongly disagree, or something like that. So you couldn't say, I don't know. And it was very frustrating. So I don't know how accurate their responses to that question was, because I think a lot of people probably didn't know. Yeah. All right. So, so I think but on the other hand, so when you design a questionnaire, just talking about the type of response that you can allow for, part of doing a questionnaire is you'd usually be using it for quantitative purposes, so to quantify a group of responses. So you do need to offer closed-ended questions where you might give the yes or no option, or a don't know or not applicable as well. But you could give other kinds of responses, but you also don't want to, you can, in sociology, for example, researchers can use questionnaires which have pretty much every question open. I used to work with a researcher in Durban who his questionnaires he never had closed-ended questions on his questionnaires. They were always very open-ended questions. But usually you'll usually be doing that with a particular purpose in mind. So you'd be sort of exploring an area rather than kind of describing or explaining a particular problem. So it can work, but usually questionnaires will have a number of closed-ended questions, but you can always leave the option open for the person. You can include questions which are open-ended, which then allows the person to say what they want to say about the issue. I recently advised a student who was doing a project on, they want to develop a program for some students, but they hadn't asked the students what they thought should be on the program on the questionnaire. So I said to them, no, you kind of dictating what the program should look like, but you should ask them what they think they would like to know about, and that's the, so that was the suggestion for that questionnaire, using more open-ended questions to say, what would you like to be included on the program, which is a good way of allowing the person who's participating to have their say. Okay, good. Yes, there should be logical flow. Absolutely. Yeah. There should be clear instructions and demographic information, clear formulated questions. Yep, good. Okay, so the type of question, and measuring the construct not too long. Yes. Okay, pilot test. Yeah, good. Okay, all good suggestions. Appropriate length. Yes. Avoid bias leading questions to an extent, and then questions should be clear, concise. Yes, yeah, good. So good focus on questions. So with the bias and leading questions, that's true. But so you do want to avoid them. But sometimes when you're trying to measure people's attitudes towards something, you need to get their attitude. You need to have some kind of value attached to the statement. So there would be possibly some potential bias on the question, or some leading. The question might be slightly leading because you're trying to get the person's attitude. Otherwise, it's quite difficult to measure attitudes without being a bit provocative about a particular issue. So that's when you're measuring attitudes. There has to be, you might have to have some leading element in the, or some value attached to the question or the statement. Yeah, so that's a good. Okay, so I'm just going to share a list of things which I made up, and I'm going to link it back to where we've been coming from. Okay, just some common mistakes that we see that students make when they're designing their questionnaires. So first of all, the questions don't correspond with the constructs to be measured. So the project says they're going to be measuring a particular set of variables, and then the questions don't match with those. Important questions are omitted. So for example, there might be there's supposed to be a dependent variable which hasn't been included in the questionnaire. The ordering of questions is problematic, and there was a comment about the order should be logical, and that's the point there. Questions are poorly worded, and there's I think one of the big problems here is that when students are developing questionnaires, particularly if they're developing new questions, they're coming from a very academic position, and the questions are framed in a very academic way, but that's not what the lay person or the person that they're targeting is going to understand, because they're not sort of seeing the problem from an academic perspective. So you have to simplify the wording of the questions. Another problem is the wrong response anchors are used. So and sometimes the anchors are, if there's an ordinal scale, they put the anchors in the wrong order, so that messes up and you don't know whether the person who's answered has interpreted the scale as being in the correct order, or whether they've seen that the order is wrong and they've chosen the right answer based, so it's very confusing. Questions are not contextualized. So there was a suggestion about giving directions to the participants and so on. That's where you'd have an introduction to sections. And again, I think a common mistake students make is because they're so embedded in the research, they sort of think that everybody else is going to understand what they're meaning by the set of questions as well. So there's no introduction. It just, there's just a section A and the questions start. So there's no sort of soft landing for the participant there. Introductions to participants are absent or not clear. And then filtering, branching is not clear, or it leads to a loss of responses. So when you design a questionnaire, you can have branching questions where the person might need to miss some questions, but you have to remember that when that happens, you're going to lose part of your sample for those questions. So that means that when you're doing the analysis later on, there might be a group of people missing for some of the questions, and that's not. It might affect what kind of analysis you can do for that particular section of the questionnaire. Sometimes the length can be excessive, but that's a debatable. The length of the questionnaire is a debatable issue. So if you there's I can't remember the name of the author now, but there's an author who's written a book on scale development, and his point is that when you're doing academic research, you need to measure certain things with your questionnaire, and if you need a long questionnaire to measure the constructs, then the length is more important than the sample that you get. So you need to cover, if you need to measure certain constructs and the constructs need a certain number of questions, then that's important, and it might be more important than getting a big sample size. So the trade-off there is that the longer the questionnaire is, the more likely you are to lose people filling it out, get a lower response rate. So you have to trade off the sort of tension between the length of the questionnaire and the number of people who are going to answer it or finish answering it. And then the other problem is when you've got poor formatting, and that has impact. It has an impact on the person who's answering, because they will wonder why it's so badly formatted. And then it's also a problem when you're trying to capture data later on. If you've got a very badly formatted questionnaire, it can make it very difficult to capture the data into a system. So it means the capturing could be inaccurate, and the accurate data is then going to affect your validity of your analysis. Okay, so this is my checklist that I've developed. So do I have a sound theoretical model? So what I'm asking there is coming back to that original, when we started, one of the points was that quantitative research should have some kind of theoretical model to be tested. It doesn't have to be, but if you are testing a theoretical model, is your model good? Because that's going to affect what your questionnaire looks like. If your model doesn't have the right variables in it, or has an odd mix of variables, your questionnaire is going to contain an odd mix of measurements. So it's going to translate down to the questionnaire. The second question is the questionnaire the best option to answer your research questions? So that speaks to this issue of, are you using the right methodology for your problem? And one of the reasons why I raise this is that sometimes we get projects where the student comes to us and they say they want to do a quantitative study using a questionnaire. But when you look at the problem that they're investigating, it would be much better if they did a case study design with a more qualitative approach than using a quantitative study. So they're more using the questionnaire because their supervisor wants them to learn about questionnaires and quantitative analysis, rather than that's the best solution for investigating the problem. And that's particularly the case for situations where we don't know a lot about the problem. Usually it's not a good idea to use a questionnaire if we don't know what's going on in a particular phenomenon. Questionnaires are more appropriate when we know a lot about what's going on, rather than when we know a little bit about what's going on. Okay, the next question is, do I have clearly defined constructs and variables and measures? And that speaks to this issue of definition of constructs. And so have we got good definitions for those constructs? So sometimes when we measure things, there might be different definitions, or there might be variable quality definitions for those constructs. And the key is to find the good ones. And I've got a couple of examples later on of things that we could measure, where I'll try and link that back to the validity and reliability of the instruments. The topic of validity and reliability, because it speaks more to the operationalization of the variables, but it links back to reliability and validity as well. Okay, and then the next question is there a pre-existing questionnaire or set of questions you can use to measure the constructs? So there seems to be this understanding or misunderstanding that you can't use somebody else's questionnaire if they've because the research needs to be original, for example. But that's not, it's not a good, it is a misunderstanding. So when somebody has a good questionnaire measure or good instrument, and it doesn't have to be a questionnaire, any kind of measurement that you're doing, if there's a good example out there which has been proven to be valid and reliable, then you would want to use it, because you know that it's going to, the chance of it working for you or your student is much better than developing a new one that might not work and still has to be tested and validated anyway. So it's not wrong to use pre-existing questionnaires or parts of questionnaires, but you might have to find out about permissions of use. So some researchers will publish their work or their instruments, and some instruments will be available and usable. Others you might have to write to get permission to use the instrument. But and sometimes you can work out what the instrument would have looked like from the publication, for example, even if they haven't given you an example of the instrument as it looks in its raw form. You can probably work back to what it should look like. And then the next question is this pre-existing questionnaire set of questions valid and reliable? And that's also an interesting question, because usually the authors will have demonstrated some level of validity and reliability if they're using a questionnaire, for example. But there's not, I always joke that academics have huge egos, and it's not a good joke, but and that they like to promote their own research. But some researchers we have to do that as part of the academic environment, that we're promoting the work that we do. So but not all work is good quality. So there might be somebody out there who's promoting their questionnaire, but it's actually not a good questionnaire, and they're using the evidence that they've sort of developed to show that it's valid and reliable. But when you look at it carefully, it's not actually a good instrument, and so you need to kind of be, you have to use discretion and critical analysis to decide what is a good questionnaire, what is a bad questionnaire. And sometimes questionnaires which have been used extensively are not actually that good. So it's difficult to, because they've been used so much, they're commonly out there. So yeah, that's just a warning about the quality of the work out there. Just because something is published doesn't mean to say it's excellent. That's the moral of the story there. And also to be aware that some researchers are promoting their work with vigor, shall we say, but it might be that their work is not that good quality. Okay. Yeah. Then the next question is, are you clear about what you're going to measure in each section of the questionnaire? So the questionnaire should be made up of sections, and then each section should, and there was a suggestion about that in the chat about structuring the questionnaire according to different purposes of each section. And that's fairly straightforward. But having said that, it's quite, students often don't, when they're developing a questionnaire, they often develop quite sort of messy, they don't sort of think about the sections or having sections and having a theme for each section. They just sort of bunch everything together, or they mix things up. And even within sections, so a common mistake that they make is with the first section, or might be the last section, where the demographic and background information is. They'll have a sort of demographic question like, what is your gender, and then they'll have a work relate, how long have you been working, and then they'll have what is your age. So there's the questions don't follow in a logical sequence. Am I clear what form each question should take? So that relates to the when we ask questions, we can ask different kinds of questions. So there's different forms of question. So Tony was talking about having yes, no. That's a very simple version of a question. But you can have different questions where you ask people to rate things, where you ask people to give a number. So there's different questions can take many different forms, and the question is, the question is what kind of question is going to give you the best kind of information for your problem. Then a very critical question is, am I clear what type of response will result from the question? And the reason why I bring that up is because there's three main kinds of response types. There's a number, well, all responses will be numbers in quantitative research. Or no, that's not true. Of the three main types of questions, response types that we can measure, they will all take the form of a number when we convert the information into a database for analysis. So there will be exceptions. So that you can ask text questions which have a text response or a date response or something like that. So there are other forms. But for the three numeric forms, there's three types of question that we can ask, which give us different kinds of answers. Those, I'll go into a bit more detail about this, but the key thing about those is that they have a implication for the kind of statistical test that we can do with that data. So the type of question that you ask is going to influence the kind of statistical analysis that you will be able to do later on. So everything is linked together. Remember that image of the chain, the linking of the chains, and if there's a weak link, then something won't work, or something that breaks down. Again, the kinds of questions that you ask in a questionnaire will influence the kind of analysis that you will be able to do later on. Okay. Another question is, do I have an analysis plan? So usually when you start the research, there should be an analysis plan, and that's usually very weakly done by students because they haven't done analysis before. So they don't know what the plan should look like. But it's quite important in the beginning to know what analysis you might be able to do, because that's going to help the design as well. You don't want to not know what the analysis is going to be, because then you might not design the questionnaire to get that analysis. And that does happen. We've had projects where the student might have said they want to do this kind of analysis, but they can't do it because they haven't used the right questionnaire to measure that. Okay, then there were some comments in the chat about the wording of questions. So your wording must be clear and unambiguous. I spoke a bit about that, where the tendency is to, if you're creating new questions, to create sort of fairly academic worded questions, but that's not helpful for the participants. Okay, then have I included important information and instructions for the interviewer and the participant? And are these clear? And maybe I shouldn't have used the interviewer there, but because given my comment about interviews and questionnaires, but yeah, I suppose the field worker would maybe have been a better option there. But yeah, so it's just about guiding the participant through the questionnaire and making sure they understand what they need to do. When you develop a questionnaire, or when you use any instrument, if there's a person involved, you need to explain the ethical requirements to the participants. So usually with a questionnaire, you would have an introductory letter which outlines how you're meeting the ethical requirements of the institution. So that would speak to confidentiality, anonymity, right to refuse to answer questions, those kinds of issues. Is the questionnaire a suitable length? That question, what is suitable length is debatable. So depending on what you're doing will determine the length, or what the student is doing will determine the length. You can get very long questionnaires, and you can get short questionnaires. Just for online surveys, if the online surveys tend to work better when they're a bit shorter, as opposed to paper-based questionnaires where you might have more control over who gets it and the sort of mechanism that they can use to fill it out. Okay, then a clean, efficient layout is also important. The questionnaire must look neat and be well designed. Then more questions would be how are you going to administer the questionnaire, and what are the implications for the response rate. So if you're going to, are you going to do a paper-based questionnaire, or is it going to be an online questionnaire? Or is it going to be a telephone questionnaire? There's different ways of administering the questionnaire, and that will have implications for how many people answer. It'll have implications for your control over the sample, and this kind of thing. So it's more difficult to monitor sample responses when you're doing online, for example, if it's anonymous and online versus anonymous and sort of coming from where you're delivering to an organization. It might be different. It's more difficult to see what's going on with the online survey, who's responding and who's not responding, unless you build in some kind of check of who, but then it wouldn't necessarily be anonymous for the participants. Then, do you need to pilot the questionnaire? I think there was a comment about piloting. It's always good to test the questionnaire with a small sample to see if they understand the questionnaire and the questions, and they can comment on the length and so on. Have you taken the necessary steps to ensure a good response rate? So there's certain things that you might be able to do to improve the response rate. Sometimes you might not have much control, but there might be steps you can take to improve the response rate. So one thing there would be, for example, the controversial possibility of offering some kind of incentive. So I think some departments would say it's not a good idea. Other departments would say it's probably all right, depending on what the incentive is. So that's a debatable issue. Some organizations would provide some kind of incentive for participants to answer. So, for example, with StatsSA, they have these very long questionnaires. So what they do is they might give the participants an airtime voucher or some kind of food voucher to encourage them to participate, because they need to get the sample sizes for their studies. And then the last question, I think it's the last question, is can I measure reliability and validity from the questionnaire? So not all questions and questionnaires will allow you to measure the reliability and validity. But as I've demonstrated, you can do it if you've got the right data and you've got the right variables and the right size data. You can measure reliability and validity if you've got the right information. Yeah. And then it's also important to note that a number of these criteria would apply for other research designs as well, not just for questionnaires. You'd also ask these same questions of other instruments as well. I'm going to skip through this. Okay, because we've been through that. I'm going to skip through quite a few of these slides. I want to get to the point where we are looking at operationalization of constructs. Okay, so this is what I wanted to talk to a bit more about. I hope that this is right. So operationalization refers to how we measure a specific variable. So we've defined the constructs that we want to measure in our study, but now we want to operationalize them. So we want to convert that definition into a measurement. So it's basically taking a definition or a sort of abstract construct and then converting it into a measure to make it easy to examine and discuss. So we need to be able to measure something. So we have to be able to convert it into a measurement, which we can then measure and then analyze. So that's the idea behind operationalization. So some concepts can be very clearly defined and operationalized. So for example, weight we know what weight means. And it's almost like we don't really need a definition because it's so obvious. And then we have very good scales which can measure weight to a very high degree of accuracy. For example, it could be the weight of a person or weight of an object. But quite often there isn't a single definition for a concept. So, and there might be different ways of measuring the concept as well. So that's where things become more complicated, and particularly with yeah, so I think in the science disciplines, the things that we measure are often much more clearly defined and more clearly measurable than they would be in the social sciences, where because of humans, because of the way we conceptualize things, there's much more debate about what things are and what they mean and how they can be measured. So if you think about something like performance, the word performance it's quite a broad word, or service quality. Those kind of outcomes, those would be outcome variables, but they could have different definitions and they could have different ways of being measured. Okay, so one of the tools I use, one of the resources I use a lot is a chapter by Blakey called Sample Research Designs, and the reason why I use the chapter for the students is because it's got a very good linkage between the conceptualization of the research and then through to the analysis plan and so on. So and then he has this example of how he gives an example of operationalizing the constructs that they're using for the study. I'm not going to read this, but it explains how because I've got some other examples further on. But what they do is he explains how this concept of the environmental worldview is going to be measured for the study. So that he provides the definition earlier on, and then he says this is how we're gonna measure it. And this is what I think is quite often missing in student proposals, is they kind of have they conceptualize the study, and then they give you the methodology, but they don't tell you what's going to be measured. They don't sort of explain in any detail what's going to be measured with. So if they're using a questionnaire, for example, there's nothing there about what this questionnaire is actually going to be measuring, and that's where the sort of the problems come in with the proposals. So there's a lack of understanding that they need to have this level of detail in their proposal about what's going to be measured. Yeah, and then this is another example. Yeah, so this is okay. I'm just going to talk about this quickly. Is there a pre-existing questionnaire or set of questions I can use to measure construct? So if there is an existing questionnaire or an existing instrument, so this could apply in social sciences or health sciences or education, all the different disciplines where there might be an existing instrument. You've got different options there to use the entire questionnaire as it is, or to use selected questions, or to develop your own questions. So a mix of some of the questions and then to adapt what's there. So it's more of an adaptation than to rather say adaptation of questions rather than development of questions. But you can also develop your own as well. So you as the researcher, or the student as the researcher, would need to decide whether they're going to use all of the entire instrument or part of it. And that will depend on what the purpose of the research is. So it's a decision that's not necessarily that easy to make. But it will have implications for number of questions you have in a questionnaire, that kind of thing. So but you have these options, and each option has implications in terms of the validity and reliability maybe of the questionnaire and so on, of the instrument that you're measuring. So if you only measure a portion of, let's say for example, we're dealing with that topic of entrepreneurial orientation, and there's 3 subdimensions, you might say, okay, I'm only going to use 2 of those. So you wouldn't be able to test the full structure. You'd only be able to test part of the structure, and you can still do that. But yeah, it makes things a little bit different to what it was originally. Okay, and this is just to make the point that it's not plagiarism to use another researcher's questionnaire as long as you've got permission and you've cited and acknowledged the use of the instrument. So you can often work out the questions by reading the tables in a paper, but you do need to provide the acknowledgement and permissions where it's explicitly stated that you need to get permission. Sometimes, I know students sometimes have problems with that, where they'll contact the researcher and then they don't reply. So it's happened recently with a student I was assisting, where they approached the originator of the instrument and they didn't reply to them to say they could or couldn't, so they had to find something else. So it can be a bit awkward, but most researchers normally will respond. Okay. Then the other important point to make is, so one point is that if you use an existing questionnaire, you would be able to compare your findings to the findings of other researchers. So that would be a good, that would be helpful. So you can, as long as it's a good questionnaire, that's the other thing to say, is that as long as it's a good instrument, then you can sort of, that's also a form of validation. So if you get similar results to other people that have done the research before, that also validates your results to some extent as well. And it shows that you can, speaks to that issue of ecological validity, where you can sort of, your results can be extended to other contexts. Okay. And then just as another important note is, if you decide to design your questionnaire from scratch, you would need to perform that process of reliability and validity testing before you can claim that your instrument is valid and reliable. And I saw a quote recently where the quote said, you can't demonstrate validity with a single study. You need to do more than one. You need to run your study more than once to be able to argue that you have a valid instrument if you design a new instrument. Okay, I've made this point before. Not all existing questionnaires are good quality. So you need to be able to evaluate the reliability and validity of existing questionnaires. So yeah, sometimes people are promoting their idea. Okay, I'm just not sure. I'm just want to go back to the teams. No. I want to do that. All right, so this is just an example of, it's not really, I don't want to go into detail about this, but it's just to kind of talk about certain kinds of variables. So it's just, it's a paper by about industrial psychology students' attitudes towards statistics. And the aim of the study was to determine the reliability and validity of the survey of attitudes towards statistics for a South African sample. So the study wasn't about, it was testing the validity and reliability of an instrument for a South African sample. And then also to determine whether particular biographical variables influence students' attitudes. So then they go into the sort of academic part of it, is that attitudes is a multidimensional concept that consists of affective and cognitive and behavioral components. And they've got these different components that they make up. So that's the definition. And then they operationalize the definitions by, they have an instrument called the Survey of Attitude Towards Statistics, which is designed to measure 4 facets: affect, cognitive competence, difficulty, and value. And then they extended the 28-item version to a 36-item to include 2 additional components: interest and effort. So they, so here they're talking about how they operationalizing these different aspects of attitudes towards statistics. Okay, and then in terms of the makeup of the scale, so affect is measures students' feelings towards concerning statistics. So they've got the statement, I'm scared by statistics, and that's 6 items. So they use 6 questions to measure this thing called affect. And then cognitive competence investigates students' attitudes about their intellectual knowledge and skills. And there, one of the questions is, I can learn statistics, and that has 6 items, and so on. So it's just kind of showing what the these different subconstructs, which are part of the broader idea of attitude towards statistics are made up of these different number of statements. So that's the measurement. So this is how the concepts are being formed into a measurement. And then these are some examples of the questions. So effectors, I will like statistics. I will feel insecure when I have to do statistics problems. That's a negative statement. I will get frustrated going over statistics tests in class. That's again a negative statement. I will enjoy taking statistics courses. That's a positive statement. So what they've done here is they've mixed up positive and negative statements to measure this thing called effect. And you'll see that there's usually a value attached to the statement. So it is a bit leading in the sense that, so I will feel insecure when I do, I will get frustrated. You have to have that sort of value in order to get the person's rating of that statement. It would be very difficult to measure this without using those words like insecure, frustrated, under stress, enjoy. So that's the idea behind the measurement. So we basically have two types of measurements. So in social science, we often work with these, the social disciplines, we work with what we call latent constructs. So this would be an example, effect would be an example of a latent construct. We can't measure effect using one measurement. We have to build a scale or build an instrument which will measure that idea of effect. One question won't really measure the complexity of that construct. And the same thing with cognitive competence. We need a number of statements to try and measure that. A single statement probably wouldn't be enough to measure something called cognitive competence. We need to have more statements or a number of statements measuring it. Okay, and then the opposite of that latent construct is a latent construct is a construct that can't be directly measured or observed. So we have to build it. We have to make up from a set of questions. Whereas a manifest variable is a measurable and observable and observable variable. So, for example, we can measure if a household has access to electricity. We can measure a person's age. We can measure a person's weight. The person might not give you the right answer to it, but theoretically, in principle, we can measure those things because we've got good definitions and good ways of measuring those things. And in science, I think a lot of variables in science are manifest variables. So if you're using a piece of equipment to measure a variable, because you're using the machine, and the machine is calibrated, and the machine has a very clear way of measuring the whatever of interest, the variable of interest, it's likely to be much more likely to be a manifest variable than a latent variable. Whereas when you're dealing with human behavior, human attitudes, human opinions, you're more likely to need some kind of latent construct to measure those variables. Questionnaires can include both, a combination of both. Okay, and then I've dealt with that. We're not going to measure each section of the questionnaire. We'll talk about that. So questionnaire sections, we normally have section A, B, C. That's just obvious speaking. So you could have in section A, you could have your biographics. Section B, you could have your measurement of your independent variable. And in section C, you could have the measurement of your dependent variable if you're using a model, or if you're testing a theoretical proposition with your questionnaire. Questions can be closed, open, factual, non-factual, leading or neutral, primary and secondary. So these are different kinds of questions. I'm not going to go into detail about them. And then you can have questions which are a statement. You can have questions which occur as a list. You can ask people to choose from a list. You can ask people to answer yes or no, agree or disagree with a statement, and so on. So there's different kinds of questions you can ask people to get responses for whatever you're measuring. This is really important for statistics. So when we measure, when we use questions, we can get three types of response. We can give more than 3, but these are the responses which occur as numbers for our analysis. So there's nominal or ordinal or numeric. These are related to the statistical test that we can do later on. So if we I'm not going to ask you, but the numbers, an example of a question which will give you a number. Maybe I should ask you. So give me an example of a question which would give me a number as an answer. So it would give me a number as an answer. So a question and a questionnaire which would give me a number, either a discrete number or a continuous number. Yes, what is your age in years? Okay, you could ask age in categories, but yes, if you asked raw age, that would be a good question and which will give you a numeric response. Okay, any other examples?
What is your height?
Yes, yeah. What is your height? What is your weight? Yeah, all those questions. Yeah, so how many hours do you spend watching television each week or each day? Those kinds of questions will give you a number as a response. Okay, the second kind of response option is what we call an ordinal question. So can you give me an example of a question which will give us an ordinal response? Ordinal also means scale. So there's some kind of scale involved to the question. So what is an example of a question which would give us an ordinal response? Yep, score your pain between 0 to 10. 0 is no pain, 10 is most severe pain. Okay, good. So that would be an example of there's a scale involved there where the low part of the scale is no pain and the high part of the scale is kind of severe pain. Most of the questionnaires that you would fill out for institutions would have these kinds of response options as well. I can see typing, but nothing's coming up. Okay. Strongly agree to strongly disagree. Yep. Yeah. Okay. That's the anchors. So that would be an example of anchors that we use on questions which give us which would be an example of an ordinal response. So you go strongly. So the question would be the GNU government is an excellent initiative. Strongly disagree, strongly agree. So it's you, and again there it's a bit leading because you've got that word excellent in the phrasing, but you want to get the person's opinion of the GNU government. So you have to kind of add some value. You have to attach a value to the statement so that you get the person's sort of attitude towards that particular issue. Demographic distribution. No, not. It's not ordinal. That's the next one. So, so ordinal, there has to be a scale involved. So that unless you're thinking about demographic distribution in a different way, that would be that's a different kind of response. Okay, small, medium, large. Yep. Okay, a rating scale, socioeconomic status, yeah, low, middle, high. Yep, good. Yeah, so it's basically any kind of question where you're going to get a sort of rating from low to high, or strongly agreed, strongly disagreed, no extent to a large extent. Cold, warm, hot. Yeah, that's slightly better. Yeah, okay, it is better. Good. Okay, so there's a kind of rating to the scale that you are providing. So let's just talk about that a bit more. So, sorry, just for the last question, the last type, I'm going to go into more detail about ordinal questions. The third type of question we can ask gives us a nominal or categorical response. So what would be an example? So we've had questions which give us a number. We've had questions which give us a scale. There's also questions which give us a category or a nominal, what we call a nominal response. So what would an example of a question be that gives us a categorical response? And there was an example of one in the group, in the chat, sorry, So are you a smoker? Yes, no. Yeah. So a yes, no response is an example of a categorical response or a nominal response. Also, that question earlier on the demographics, the demographic group. If you had a question, which demographic group do you identify with? That would be an example of a categorical question or a nominal question. What is your blood type? Yes, A, B, A, O. Yeah, so that would be an example of a nominal or categorical response. Gender. Okay, nationality. Yes. So these are good examples of nominal or categorical responses. So there's no inherent, whether you say A, B, or O A, B is not, it doesn't have any there's no significance to the sort of ordering of the responses. There might be socially, but whether you present your gender as male, female, female, male, the ordering of the categories is not doesn't have any sort of meaning. It's not like a number where you go 1 to 1,000, or where you have a scale which is going from disagree to agree. Okay, so those are the main types of response option, and I'll show you how they affect the stats analysis a bit later. So with ordinal responses, I don't know if I've got there's a very good handout that I have, which I'll share with you. Make a note of that. In fact, I can try and load it up now just to show you about, it's going to load it up quickly because I think it's a very useful handout for students if they're doing, I just need to get to this directory. It's a very good handout if your student is doing work using ratings of, say, people's attitudes or people's, I've got it under my directory called useful for students. And now it's not showing properly. So let me try that again. Oh no, okay, it's showing up now. I'm not having a good day today. Okay, I think there's the universe is conspiring against me. Okay, so let's go share here. Okay, this is the handout from Vegas with Likert type scale responses. So people often refer to these response options as being Likert responses, but Likert is a very specific scale. So it's not if your student is using these scales, they must refer to Likert type scale, not a Likert scale, but rather just avoid the word Likert completely and just use the word ordinal scale. Then it's more appropriate. So this is a handout. I hope you can see it with different options for. So when you're measuring, when you're using a scale to measure, these are the kinds of things that you can measure. So you can measure the frequency of something. So that would be never, often, always. And they've got different examples of frequency scales here. So that's useful. So if you want to measure how often something's happening, You could use the frequency scale to say it never happens, it rarely happens, it often happens, for example. So sometimes with, say, in management research, you might say to the employee, how often does your manager do these certain behaviors? And you would say never really, sometimes, often, always. And that would indicate the degree to which the person is doing what you might expect them to do. There's also agreement. So this is we use agreement for attitude. So this is if you want to know whether somebody agrees or disagrees with a particular phenomenon or a particular policy or a particular issue, the agreement scale is a good scale to use for attitude measurement. So you might say you could, and it's usually you'd have a sort of slightly, well, sometimes a fairly loaded statement. I'm just going to use an American politics example. It would be best if Kamala Harris wins the US election in November. Strongly disagree, strongly agree. So that will give you an indication of whether the person's answer to that question will tell you whether the person is more Democrat or more conservative. For example, it's not conservative. What do they call them? Republican. Yeah. So depending on how they agree to that, how they answer that statement. So that gives you their attitude towards that political question. Then you can have, there's also, this is not showing up properly now. That's why it's not, I don't know what's going on with my computer. If you want to ask somebody about their, so if you give the person a question about a change in something, let's say, for example, you want to know whether there's a positive or negative attitude towards a change in teaching program, for example, you can say to the person, this is going to change. Do you oppose or favor that change? And then you've got a scale here which would do level of support opposition. There's also a quality scale which is not showing up on my machine is doing. It's not showing up here, but there's a very useful quality scale. So if you're measuring the quality of something, so like performance, you might say, please rate your organization in terms of their financial turnover. And then it would be, you've got a scale there, very poor through to excellent. You can measure the importance of a particular issue to somebody. There's an importance scale here. So this is a very useful handout for working out what you can actually measure around a particular issue. And it's a very good, it's a very useful tool to use. Yeah, so there's unfortunately the second part of it is not showing up, but there is a second page. Okay, so that's the Vegas handout that I was referring to here. When we measure scales, I haven't loaded this again, so let's get this back up again. When we measure scales, there's a big debate about ordinal scales in terms of how many about balancing the responses and using neutral, and whether we use a 5 or 7 point scale, or whether you put the negative end or the positive end first. So when you use an ordinal scale, the scale should be balanced. So if you've got a strongly disagree, you should have a strongly agree. And that's important. Sometimes what the students do is they mix up they don't get the ordering right, and that's where things can go horribly wrong with if they collect data using the scale in the wrong order. That can really throw out the reliability of the scale. So it's very important to make sure they get the scale going and the sequencing is correct for the anchors. There's also debate about using the neutral scale. So the neutral is the middle category. So you would say strongly disagree, neither disagree or agree, strongly agree, that neither group in the middle. The reason why it's sometimes you want to force people to make a decision about the issue. So they must either say agree or disagree. So by leaving out the neutral, you force them. But that also brings you back to that point that Tony made earlier about giving people the choice of an answer that they want to make. So if you remove the neutral and the person wants to be neutral, then it's a problem because you've taken away their option. And the other problem with the middle category is that I think people misunderstand it to be don't know, which is different to not knowing about something, is different to being neutral about it. So if you think about that question about who should win the American election, if you're neutral, you don't care either way. It doesn't matter to you which person wins. If you don't know, it means that you don't know enough about the situation to be able to make a judgment. So there's a big difference between don't know and neutral. So normally, if I think there's going to be don't knows in response to the question, I'll suggest that the student adds in the don't know, but they can also throw out the analysis, because then when you get don't knows, you have to work out how to deal with them, and then they're annoying because they don't, you can't, in some ways you can't use the data for the don't knows because they haven't given you an answer. They haven't rated the statement, but they're not really neutral, so you don't want to put them in the middle. Sometimes some people put them in the middle, some people will leave them out. It depends on how many there are, essentially, as how to deal with that. So they can be a bit of a problem. So I think mostly we do leave the neutrals in for the work that we do. But if you get a lot of people sitting in the middle, it might mean that they don't know. So but then you probably be able to work that out anyway. There are debates about how many points the scale should have. So you can use 3 points, you can use 4 points, you can use 5 points, you can use 10-point scales. So there's different debates about that. Most of the scales we use, I'd say, are 5-point scales. That seems to be the most common kind of usage. But it will also vary depending on what you're doing, what you're measuring. And then we normally put the negative end first. So if you've got a scale, I'd normally say strongly disagree, strongly agree. So we'd start with the strongly disagree. The reason for that is that when you do the analysis and you're writing up the analysis, we tend to associate higher scores with better kind of meaning, and lower scores with worse meaning. Except sometimes it works the other way. If you talk about somebody coming first, second, third, then the first is the lower number. But it's kind of at the top. So but generally, I did some research many years ago now where we used an opposite scale. So we had the positive end at the lower number and the negative end at the high end, and trying to write that up was an absolute nightmare, because you were kind of writing about a small score meaning something negative, and it was just a low score meaning something positive, and that was very difficult to write up about. And it was ever since then I said I'm never using that a low score as a positive score. So what you can do is present the questionnaire with the positive end first and then the negative end at the top, but then you can also reverse it when you do the analysis. So there are ways of getting around that. But I just prefer to just leave it as it is and just work with that. Okay, this one, moving on. Okay, then there's also debate about should you put an anchor on each end of the scale only and then leave out the points. So what that means is if you've got 5 columns of responses, so it would be strongly disagree, and so on. Do you put an anchor on each column, or do you, which is the word that you want the person to rate, or do you just put the anchor on each end? So you have a strongly disagree and a strongly agree. So I prefer to put the anchors on each column so that when the person reads the scale, they're seeing the same word there. So you're not going to get any sort of confusion or people not knowing what the 2, 3, 4 mean, because they might have a different interpretation of it. But sometimes you might, so if you think about that pain scale, you're not going to have, it's quite difficult to label 10 points or 11 points. So you're going to have no pain and extreme pain, and then the person would rate. But I think it's easier to do that with 10-point scales than it is to do it with a 5-point scale. The negative positive statements, which we saw some examples from the previous example, is a problem. So people use negative and positive statements to keep the respondent honest. So it's a way of making the questionnaire more engaging for the participant. But the problem is, statistically, what we found is when you give negative and positive statements to the person to rate, they don't rate those negative and positive statements with the same strength. So when we come to do the analysis, when we do that confirmatory factor analysis later on, usually the negative statements don't fit so well with the positive statements, because we have to reverse them to get the analysis to work. But then the strength of the rating doesn't always come out as being the same. So they might rate the positive statement more strongly than the negative statement, and so they don't correlate when you put them together. So often we end up dropping negative statements from the analysis because they don't have the same effect as the positive statements. And then you don't want to lose too many statements from your construct. So what that means is you need to make sure that you have enough positive statements or negative statements to be able to build the construct, to be able to make the construct, in case you need to lose some of the items from the analysis. And then the other issue is about using mixed response categories. What that means is that you have statements, but then you're using different response options for the different statements. So you might have an extent. You might have a frequency scale for the one statement, how often does something happen, and then you might have an agreement scale for another statement, which is measuring the same construct. So we tend to use the same. Most of the work that we do, we tend to use the same response options for the statements, but we have worked on projects where they have used mixed responses, and it has worked. So it can work. Okay. And then importantly, do you have an analysis plan? So this is it's quite difficult to see this table. So I'm just going to talk to it. We'll come back to it when we get to the analysis of data. I'm just going to make this a bit bigger. I don't know, I can make this bigger. I think you might be able to make it bigger on your screen. So what this table shows, it's a decision-making tree around statistics. So this is making the link between the type of variable that you've measured and the statistical analysis that you can do. And often students don't have good analysis plans, but they should have in their proposals. They should have some indication of what analysis they're going to be doing. The way the table works, on the right-hand side, these are statistical tests. So there's a list of statistical tests on the right-hand side. And then to get to the test, you need to ask a set of questions. So, I'll explain the first question is, how many outcome variables do you have? So how many dependent variables do you have? And the options are 1 or 2 or more. The next question, which relates to the type of question that you've asked, is what type of outcome variable is it? Is it a continuous variable or is it a categorical variable? And for the purposes of this table, we would group ordinal and categorical variables together, and continuous variables are our interval numeric variables. So I'm just going to use an example here. I'm going to just choose the first option, which would be it's a continuous variable. So let's say we want to test, our theory is that male and female students are going to perform differently on a course. So our outcome variable is their academic performance, the mark that they get for an exam, and that's going to be a continuous variable. Okay, we've got one continuous variable. The next question in the sequence is, how many predictor variables do you have? We're going to say there's going to be one variable. It's going to be we're just going to use the categories male and female just to simplify the example. The next question is, what type of predictor is it? And the options here are categorical or continuous. So again, the type of question that you've asked in your questionnaire or that you've used for your measurement is going to determine what kind of test you're going to be using. This could apply for any kind of statistical analysis. If you're doing an experimental design, this table will apply for that design as well. So if you're doing an experiment, where you're measuring a particular variable. We'll try and use an example of that now. We could work through the table in the same way. Okay, so we've got a categorical predictor. The next question is, if it's a categorical predictor, how many categories do we have? So it's 2. We're just using male and female. We could use more. We could use male, female, and other, and that would give us more than 2. But for this example, I'm just keeping it simple, just to say 2. Okay, so that's our male-female grouping. The next question is if it's a categorical predictor, do we have the same participants or different participants in each category? So if you think about groups of male and female, are they different or are they the same? They would be different. So we've got a group of males, we've got a group of females. So we're going to choose the different option here. I'll explain what the same will be in a minute. And then the last question is, do our data meet the assumptions for parametrics tests, yes or no? So we've got one dependent variable, it's a mark, so it's a continuous variable. We've got one independent variable, and it's a categorical variable. We're going to use 2 groups, and the groups are different. We don't have the same people in the groups. Okay, and then let's say that we say yes, our data does meet the assumptions for parametrical tests, and I'll talk more about that when we do the stats sessions. And then that would mean we would use an independent samples t-test for that analysis. Okay, so the test that we would use for that analysis would be an independent samples t-test. Okay. Let's use a different example. So we've got, let's say, a scientific example. So we've got one outcome variable, and that's going to be, I'm just trying to think of an example quickly. Having a Dorf moment here, sorry. Okay, let's use, I can't see this picture very well. Logistic regression. Yeah, okay. Let's use this example here. Okay, so we're going to this example. We're going to use a scientific experiment. So we've got one outcome variable, which is the survival, the death or survival of a sample of seeds. So we're applying different treatments to a group of seeds, and we want to know whether the group of seeds survives or dies. So that will be the outcome variable will be a categorical variable. It will be either death or survival. Then with the predictive variable, I'm just going to keep it simple. We've got one predictive variable, which is going to be different amounts of light, for example. So that's going to be a continuous variable. So we're going to apply different lights of light to groups of seeds, and that's going to determine whether they live or die. And if we follow that design, we're going to go straight to the test. We're not going to because we're using a continuous variable as our independent variable, we don't have any questions about the groups or whatever in the independent variable. And that's going to take us to logistic regression, which is the procedure that we would use when we have a numeric independent variable, an interval or continuous independent variable, and a categorical dependent variable. So that's the kind of decision making that we need to use. So if you know what variables you're measuring, and you know what type of variables they are, you should be able to work out what statistical tests you're going to need to do the analysis, and that's why that's what the students need to include in their focus in their analysis plans. Okay, I'm just going to go through this quite quickly because it's fairly straightforward. This is wording of questions, language. So when you're wording questions, you need to be careful about the language. You need to make sure that the questions are relevant to the respondents, and that comes back to also validity issues. If you're not targeting the right kind of sample for your questions, you're not going to get useful answers. So that would sort of the participants need to know, need to be able to answer the questions that you're asking. The information level, that speaks to more specifically to the person having the knowledge to answer the questions. there's not much point in asking people about questions, excuse me, that they can't answer. Questions must be simple, so reduce the complexity of the question. And so in terms of accessibility, there's certain questions that some participants might not want to answer because of sort of sensitive or cultural reasons. And you need to take that into consideration as well when you're designing a questionnaire and designing questions for the questionnaire. There's attitude statements are quite difficult to develop, and I've got a good sort of resource that I use for that, which is by an author called Oppenheim, who kind of provides an example of a workshop where they're developing statements to measure sexism, chauvinism, and androgyny. And he kind of gives examples of the questions and then makes comments about how appropriate, whether that question is appropriate or that statement is appropriate for measuring attitudes. So again, that's quite a nice example to look at if you're thinking about designing attitude statements for latent variables. Okay, I think somebody mentioned about avoiding double-barrel questions. So you need to avoid long double-barrel, double negative, and loaded questions. A double-barrel question is a question where you have an and, where you might say, do you like apples and pears? Because you might like apples but not pears, and then you can't answer the question because there's an and sitting there. So you want to say I like apples and I don't like pears, but you can't really answer the question because of the and. That's quite a common problem with student-designed questionnaires where there's the double barrel comes in. Yeah, and then also there is a comment about avoiding loaded questions. But if you're trying to measure attitudes, you do need to make the statement. You need to phrase the statement in such a way where the person can give you the attitude. And that usually would involve some kind of making the statement, attaching some value to the statement. So there will be some sort of level of loading there. Don't use acronyms, technical jargon, and abbreviations. I think these are common problems in our modern society where people use acronyms a lot, for example, and sometimes I certainly find it difficult to understand what people are talking about because they've used an acronym, but I don't know what the acronym means. And then don't ask questions which require the respondent to remember too far back. So we can remember a certain amount of information from recently, but we don't tend to remember a lot of detail about things which have happened unless it was very, very recently. Okay, I think we've covered that. Yeah. So, yeah, I think questionnaires vary in length, and I think when you're designing a questionnaire, think about your own experience of answering questionnaires. When would you kind of give up answering if you thought it was too long? I think a lot depends on the topic rather than the length of the questionnaire. I think if you're interested in the topic, you will answer. I'll talk about online questionnaires in a second. And then layout is important. I've spoken about this already. It creates an impression for the respondent. It provides a clear framework for the respondent to work through the questionnaire, and it provides a framework for efficient and accurate data capture later on. If you're doing whether you're doing an online or a hard copy questionnaire, both are important. Okay, in terms of ethics, you need to notify the participant about the purpose of the research. If the responses are going to be anonymous, or it's more, I think most questionnaires are anonymous, but some of them might not be. And if they're not, then you need to alert the participant that they're not going to be anonymous. And usually most people will participate. But it's very important to inform them that if it's not going to be anonymous, that there will be they'll have to give some kind of personal information so that you can track what they're doing. You need to note how you're going to protect confidentiality. So that's basically about not sharing the person's responses with anybody else, or and it's also about protecting the data after you've finished working on it. So it needs to be stored for a certain amount of time. So there's two elements to confidentiality. One is about not sharing the data with other people on an individual basis, and then also keeping the information protected from after it's been used. The participant always has a right to withdraw from the process at any stage. So if they decide halfway through the process to drop out, then that's their right. And then they also have the right to refuse to answer questions. So one of the things that happens with online surveys is the person will say to us, please set all questions as being compulsory. And my answer to that will be saying, no, we can't. So what we do with some questions, certain questions will have to be compulsory. So for example, if you're doing a branching question, you need to make that question compulsory. Otherwise, you can't control the branching. Also, the consent question should also be compulsory, because you want the person, I'm talking about online surveys, because you need to, if the person doesn't consent, you need to eliminate them from the process. But for most other questions, we have a setting on the program that we use, which is it reminds the person that they haven't answered, but it doesn't force them to answer the question. So we deal with this issue there, because participants have the right to refuse to answer questions. They don't have to answer every question if they don't want to. I know when students set up their online surveys in Google Forms, Google Forms seems to make all questions compulsory, and that's not ethically, that's a problem, because we're not supposed to do that. If you're doing research which is controversial and sensitive, then you might need to offer the option of counselling after the research. But I think most of the research projects that we work on wouldn't have that level of sensitivity, or they're not. I don't think they would traumatize an individual to the extent where they all bring up memories or whatever that would have the where counselling would be required for anybody. And then also remember to thank the person for their contribution. Okay, and then with the piloting, you obviously want as many people to review the questionnaire and evaluate the questionnaire, and obviously the reviewer would need to know the purpose of your questionnaire to be able to evaluate it. So normally we get a proposal, for example, from the student when we review the proposals and the questionnaires. Okay, piloting doesn't have to be a big exercise. So when you pilot a questionnaire, you can use a small sample. So 30 is actually quite a big sample. But it's a more qualitative. It can be a more qualitative. You can do a qualitative pilot where you administer the questionnaire to a small number of people and ask them to give you feedback on the questions and on the length of the questionnaire and so on. It's mainly to find out whether they understand the questions and whether they understand the response options, that there's nothing throwing them off in terms of, or there's nothing that they don't understand. You can also do a big pilot where you actually do the statistical analysis. But that's, most of the projects that we work on wouldn't involve such a big pilot, because the students don't have the time to do large pilots, basically, unless they're doing a PhD, possibly. But for honours and masters projects, the time isn't there to do that. Okay. And then just a quick note about online questionnaires. So we found as a result of COVID, a lot of people moved on to online. It's not just COVID, it's also just with the access to technology. So a combination of the access to technology and because of COVID lockdowns and so on, and not being able to do field work in person, we saw a big uptick in online questionnaires, and we do get very variable results with them. So the ones that work the best are the ones where the participant has some kind of gatekeeper who can get them access to the participants that they're targeting. If the student is just targeting a general population out there, the response rate can be quite weak. So there's pros and cons of using online surveys. Some of them work pretty well, some of them don't work well, and there can be issues with one of the problems with online surveys is you don't always know who's answering. So you can send out to a list of people, but you don't really have any control over who's going to respond. Whereas if you're going to organizations in person, you can sort of get a better sense of how many people might have answered but when they hand in the hard copies and that kind of thing. But it's not, I think both methods have their pros and cons. Yeah, and I just want to quickly go, I've been through some of this already. I just want to go to I just want to make a link between, these are just examples of, I want to talk about validity and reliability of instruments. So there's this, so just very briefly, and then I'll be done. So this is a construct called job satisfaction. So there's different ways. I mentioned that there's different ways of measuring job satisfaction or constructs. And in this case, we've got two versions of this construct job satisfaction. The first one is an instrument which is a 36-item 9 subscale measure. And it's a more general kind of measurement for job satisfaction. It measures pay, promotion, supervision, fringe benefits, communication. So those are some of the things which are considered to be part of this concept of job satisfaction. Each subscale has 4 items. So each of these variables or each of these factors is made up of 4 items or variables. And then a total score is computed for all the items. So they kind of generate a score for all the items using the scale. So this one is not, so because there's 4 questions measuring each construct, that's quite a good a sort of strategy or design, because you've got a good number of questions measuring each construct. So in terms of validity, that's quite promising. So to move this forward. But when we see the internal consistency or reliabilities, and this is based on a sample size of 2,870, the Cronbach alphas are not that good for some of the subscales. So operating procedures has got a low Cronbach alpha, and co-workers has a low Cronbach alpha, 0.60. So even 0.75 and 0.73, they're not bad, but they're not great either. So when you're trying to evaluate an instrument for reliability and validity, and in this case we're talking about reliability, these subscales don't look so good. When they do the total, it's great, 0.91, that's excellent. But when you go down to each individual subdimension, some of the Cronbach, in fact, most of the Cronbach alphas are below 0.8. There's only one above 0.8. The others are all below 0.8. So that would be considered poor, and particularly the ones below 0.7 are not good. So the question, what would you do here? Would you continue to use the scale as it is, or would you think about revising it, or you could drop those components which are weak? There's different options that you would have here for dealing with that. But bearing in mind that if you change the instrument, theoretically you should really go through a process of validating and testing reliability again. The one thing that you would be able to do, though, is you would be able to test these for your own sample if you get a big enough sample. So you would be able to check to see whether those dimensions were reliable for your study. So part of this is to say you can pick up from published work whether the scale is good or not. And in this case, I would say it's questionable. It doesn't look great. It's not convincing to me. I would maybe look for something else based on these results, because they're not that good. Some of them are okay, but some of them are not good. So it's trying to be critical of the evidence that other people have provided of their instruments, to say, this is something I could use, this is something that I don't want to use. Okay, so this, when you look at the actual statements, the pay construct, which has a decent reliability, is made up of the statements: I feel I'm being paid a fair amount, raises are too few, that would have to be reversed. I feel unappreciated in relation to what they pay me. I feel satisfied with my chances for salary increases. So actually, it's quite, with those two negative items, which would be reversed for testing reliability, it's not a bad reliability, 0.75. The co-worker construct, which has got a weak reliability, if you look at the questions there, I like the people I work with. I find I have to work harder at my job because of the incompetence of people I work with. I enjoy my co-workers. There's too much bickering and fighting at work. So there's two reversed items there, two negatively worded items and two positively worded items. But that's giving a poor reliability. And when you look at the kind of content, it's kind of all over the place. So I like the people, I enjoy my co-workers. Those two are probably okay. But then there's this incompetence. I have to work harder because of the incompetence. It's a long statement, and it's bringing in working harder, and your staff are being incompetent. So what is it measuring there? And there's too much bickering and fighting at work. That might not have anything to do with the co-workers. It might be to do with your manager and you bickering and fighting. So it's not. So you can see why that wouldn't give such a good reliability, because the statements are not. They're not sort of as cohesive as the pay statements are. So that's that probably explains why that construct is a weaker construct. Okay, then there's another version of job satisfaction, which, so you think, okay, well, I'm not going to use that one because it's not so great. So let's look at this other one, which is job satisfaction, the Benjamin Rose Nurse Assistant Job Satisfaction Scale. This is an 18-item scale, which has got factors of communication, amount of time, available resources, teamwork, and management practices. And that's here they're saying that you need to get permission to use the instrument, but I think this was developed a long time ago, so I can't imagine these contact details apply anymore. So that's, I'm not sure what one does in those kinds of situations, whether you just go ahead and use it or find something else. So this is an interesting scale, because the communication and recognition, these are the questions that make up the scale. So communication and recognition has 5 items. Amount of time to do work, available resources, and teamwork only have 2 items each. And then management practices has 7 items. So in terms of its structure, it's very uneven. So some components have lots of items and other components only have 2 items. And if you think about the construct teamwork, to try and measure that with 2 items is really limiting. I just think that's not. It's not a good. It's not a good way to measure teamwork just with two statements. So that would probably not be a good measure. And I don't think. Yeah. So in this case, we're not measuring reliability, but we're saying 3 of the constructs only have 2 items, and we'd usually expect at least 3. And ideally more than 3. So this is not a good instrument either. So you'd have to make a decision: do you use it, or do you adapt it, or do you find something else? So this is part of the discussion around the validity and reliability of instruments that we can use to measure constructs, and being critical of them to say, is this a good design or not a good design? Yeah, and that's, so for both of these measures of job satisfaction, they're both limited. But then you have to weigh that up against if they're the only ones available, do you try and develop your own, which you would then have to test and validate? as a first step, or do you use these and take the risk that they might not work that well? So that's the dilemma of the researcher, and that's what the students have to face when they're doing research using these kinds of instruments. Yeah, it's the same thing with, and it would be the same thing with scientific work. So, for example, when I did my master's degree, I had to do some biochemistry tests on seeds, and one of the things that I had to measure was the amount of lipid in the seed, and there were different tests to measure the lipids, but I only had some of the tests were very expensive to run, because one of the things about scientific work is that you need chemicals, and they can be very expensive. So the test, they didn't have funding for me to do the expensive tests. So I had to find a cheap test, and I did a cheap test, which didn't work very well. So it's the same kind of, I don't know how good I really, to this day, I don't know how accurate the results were, because the test wasn't it didn't always work properly, and it was very unreliable. So it's the same principle whether you're doing a scientific project or whether you're doing a social science project. If you're trying to measure something, you want the measurement to be quality, but sometimes you have to work with what you've got, and that might not be the best quality instrument to use, or test. In this case, it was a lipid test. And the results might be weaker because of that, because you're using a cheap test instead of a nice expensive test. So that's a bit of a story about measurement and the link between measurement and validity and reliability. So I'm going to stop there, because I said we would stop at 1 o'clock, and I want to give you a bit of a chance to ask some questions. So I'm going to stop sharing that. So it's your turn to ask questions before we close for the day. Any questions? Is it making sense? That's the key thing. And I hope it's not putting you off doing quantitative research, for those of you that haven't done much quantitative research. That's not my intention. Are there any questions, any comments? Yes, Nicolene, yeah.
Thanks.
Yeah.
I have a few questions, and most of them are related to the validity and the reliability that we were discussing earlier.
Okay.
The first question, when we spoke about maturation validity, is that something you normally see with a longitudinal study design, or can you see it in a cross-sectional study design?
So I think you could see it in a cross-sectional if you, I think it's more to do with a sort of pre-post kind of design where you are doing an intervention, and then so you might have a program that you're administering to a group of people, for example, or some experiment that you're conducting on a set of plants or something like that. But it would have to have a time factor involved, and then something else can occur during that time which might affect the dependent variable, not the intervention that you're applying to the whatever you're waiting for to happen to the dependent variable. Yeah.
So the maturation is of each individual being tested. It's not necessarily maturation of different individuals within the sample.
No, yeah. So I think it might affect people in the sample or the objects in the sample differently for whatever happens, but it could be, yeah. So it could, but it's
the same influence on each of the individuals.
Yes, yeah.
Okay.
So everybody might experience it, yeah. So it's yeah. So, I suppose it could also be that they don't. It might be that some people experience it depending on what the event is. But yeah, it's yeah. But I think But obviously, if you've got the more control you have over if you're doing something in a lab, for example, those kinds of things are less likely to happen than if you. I think so. In education or in psychology, for example, the researcher might be applying some kind of program to a group of people or learners or patients. And then something else might happen to them, So it's just during the course. I think it's more of a time-based. It is a time-based phenomenon. So I think there needs to be some kind. If you're doing a cross-sectional, which is happening where you're taking a slice at one point in time, it's not likely to be a relevant thing there. And I think that's the point that I made in the beginning, is not all kinds of threats are going to be relevant to all kinds of research, if that makes sense.
Yes.
Yeah.
My next question is about instrument reliability. So you mentioned, and I am aware of this, where you take multiple readings using an instrument in order to check the reliability. But I have an interesting thing that came up in the last couple of years when we did some research for a paper. The instrument we used was an X-ray, and X-rays obviously have some form of radiation associated with it. And one of the comments we got from the reviewers of the paper was that in order to test reliability, they indicated that according to them, we were supposed to X-ray the same individual multiple times. So for example, 3 times at different time frames. Now, ethically irradiating someone for no reason just to test the instrument, because they underwent the X-rays because of a clinical reason. It was for clinical reasons. So I just was wondering, so we obviously did not end up doing that. But I was just wondering, is there an alternative that we could sort of look into if something like that comes up again?
I think I would definitely agree that exposing somebody 3 times is not a good proposition. But I think there might be a way is there a way you can test the machine it doesn't have to be with a non-human object to see whether it's when you calibrate, for example, there might be some kind of process that you can use. I don't know.
Yes, that's a great point. We could look into calibrating it somehow, and proving instrument reliability using something else. That's a great point.
Not a person, but some other object maybe.
Yes.
To show that it's giving the same reading each time, but not necessarily subject the patient to that kind of treatment. I think so. Usually, I mean, there's not always. I mean, obviously machines vary in how they work and so on, but usually there would be a way you could test to see whether it's working. And I think when they calibrate the machine, they probably do some work on it, or they must use some kind of mechanism to show that it's working, or working at the best of its ability. And then you could maybe repeat that and use that repetition as the evidence of the reliability of the instrument, of the machine.
That seems very logical. And then I just have one last question. I just wanted to make sure if I was understanding in a questionnaire scenario, item versus factor correctly. So an item would be referring to the specific questions you would be asking, and a factor would then sort of be like the construct that you're measuring with the questions. Is that?
Yes. That's
okay.
It.
Awesome. Thanks.
So the construct it's not a real thing. It's made up of the items.
Yes.
So when we it's like when I did that little model, the bubble, the circle, which is the factor, it doesn't actually exist. It's made up of the items. So the items make up the factor. Yeah.
And then when you're testing validity and reliability, it is to look at the items making up the factor and how interconnected they are.
Yeah, so the reliability looks at the items. So that would be a measure of the consistency of responses for the items. and then the validity refers to there's different types of validity for the factor. So there would be, the convergent validity looks at how the items relate to the factor. So we use the when you measure when you create the factor, the items, each item will have what they call a sort of item loading on that factor, so that you get a coefficient for each item. And some items can have each item will have a different value. And the convergent validity speaks to how well those items load, or the value that they have on that factor. So you could have some which are very weak and some which are very strong. Usually, if you've got a good variable, if you've got a good measurement, the items will have good sort of factor, good coefficients on the factor. And then the discriminant validity speaks to the relationship between that would only apply if you've got more than one factor that you're trying to measure. So, like, if you think about that concept of the example that I used of entrepreneurial orientation, the thinking behind that is that there's 3 subdimensions for that concept of entrepreneurial orientation. So you've got 3 or you can call them 3 factors. There's 3 factors that make up that main factor. So discriminant validity is only relevant when you've got more than one, because you then discriminant validity speaks to how the items work best on one particular factor rather than so they don't kind of load. Because what can happen with items is they can cross load onto other factors. So they can have a relationship with more than one factor. So what you want to see is that you've got they have a good relationship with one factor, and then not such a good relationship with other factors. And then it also looks at the relationship between the factors between themselves. So, and that's when I'm talking about the correlation. When you've got a very high correlation between factors, it probably means that and when I say very high, I mean sort of 0.85, 0.9, which is a high correlation, very high correlation. It probably means they're measuring the same thing, not different constructs. So that's where you would, and so you wouldn't have discriminant validity under those kinds of circumstances, because they're too interrelated. They're kind of basically measuring the same thing. You can't discriminate between the 2 factors with the measurements that you have. So that's how the 2 forms of validity would work when you have factors, those sort of latent constructs.
Is this kind of similar to intercorrelation and tolerance when you're running like multiple regression on experimental data?
Yeah, so it's not quite the same, because the regression. Sorry, there's a very good suggestion from Lindiwe about using a phantom for testing your X-rays.
Oh, thank you so much, Lindiwe.
Yeah, very good suggestion. Yeah, I've forgotten about phantoms. Yeah, so a regression it's different to a regression. A regression looks at a regression is looking at the relationship between a dependent and independent variable, and so a structural equation model, which is where you would go if you were doing a confirmatory factor analysis, you would probably then proceed to a structural equation model. A structural equation model is it's similar to a regression. It just works with items